We'll be getting started in a couple of minutes. Hello, welcome. Hi, everyone. And I'm your host today. My name is Miriam Oglesby. I'm working in IBM's developer advocacy team in Europe. Thanks for all your comments. We're seeing lots of you joining, using the chat already. That's great. So before we get started, I've got a little bit of housekeeping for you, and I'd like to give you a bit of background information. So bear with me. This won't take a few minutes. So on this channel, we have lots of talks and hands-on workshops with experts from IBM and beyond. If you would like to be notified about our future events, please feel free to follow us. There's a green button at the top left of your screen. And if we continue that tour around your screen, you can also see the bottom right-hand corner, there's the chat where it says, say something nice. There, you're already telling us where you're joining us from. That's great. It's wonderful to see so many of you. I'm seeing people from Vienna, Seville, Madrid, London. Hello to you. Big welcome. And so on the left from the chat, which you can use at any time to communicate with us, there's a green button at the bottom of your screen, and that you can click on to create or sign in to your IBM Cloud account. To the right, we also have polls, and we already have one live for you to let us know if this is your first time joining us at one of our events. And if it is your first event with us, a big extra welcome to you. And also to the left of the green button, we have an Ask a Question button, which you can put in questions for our speakers, which are related to what they're talking about, so they don't get lost in the chat. And also important for you to know is you can vote on these questions, which have already been asked, and those will shoot up to the top. So do ask questions, do vote on questions, and then you'll get to see those getting answered quickly. Great, so welcome to the Developer Festival. We're really excited that you're with us. The schedule for today looks like this. We've got the first session with Jan-Reiner Lahmann and Quantum. And in the afternoon, we've got infrastructure deployment, machine learning, and chatbots, and deploying to WhatsApp. So it's a great agenda, and we're so excited that you're joining us. So now I would like to introduce our first speaker of the day, Dr. Jan-Reiner Lahmann, an IBM Distinguished Engineer and the inventor of Raspberry. Jan, I'd love to invite you to the stage.
Yeah, thanks, Miriam. Thanks for having me, and I'm really honored to kick off the Developer Festival at this time. So in this session, we would like to speak about quantum computing. I will give a quick introduction to quantum computing. Then we will focus on what you can do hands-on yourself, how to program a quantum computer, how to create what we call quantum circuits, and also how to access real quantum computers on the cloud for free. And I think that is really exciting, that you can really try out quantum computers yourself, which is really a fantastic technology. And then in the last part, we will look at this combination of quantum computing, a Raspberry Pi, and a 3D printer. And with that, you can create your own functional model of a quantum computer at home. And we will see what it means to have a functional model. So obviously, with a Raspberry Pi, you cannot build a real quantum computer, but a functional model which can also execute quantum circuits. Okay, we will see that in the last part of the session. My name is Jan Lahmann. I'm an IBM Distinguished Engineer, 20 years with IBM. My day job is I'm the IBM CTO for one of our largest clients, and I'm very passionate about quantum computing and spend a bit of time around that. So as Miriam already mentioned, there are some polls. It would be great if you have a look at these and answer them. I will have a look at the answers and maybe also make some comments about that. So let's get started. Quantum computing, I mean, it's a very high focus on that. People expect that it will maybe change the world or a part of the world, and others say it will not work. Yeah, and that you can also see when you use the type ahead feature in a web search. Yeah, when you type quantum computers will, then the type ahead, the first option is never work, and the second is change everything. And a bit of these both sides, yeah, we will explore and discuss in this presentation. When did all that start? Actually, 40 years ago, or around 40 years ago, there was a conference hosted by the MIT and IBM, where Richard Feynman, a physics Nobel laureate, discussed an observation and then an idea. Yeah? And his observation was that if you want to simulate quantum mechanical systems, yeah, on a traditional computer, then it requires very, very high, yeah, capacity of the computer, long computation times, and high memory requirements. And that even with, let's say, small quantum mechanical systems, it is more or less impossible to simulate them on traditional computers. So, I mean, that was an observation, yeah, and even with Moore's law and the increase in speed and capacity of traditional computers, that is still valid, yeah, and it was clear to him and to many others at that time. And then his idea and his suggestion was, well, what if we would build completely different kind of computers that make the quantum mechanical effects like superposition, interference, entanglement directly accessible and controllable. And with such a different kind of computer, it should be much, much easier to do these simulations of quantum mechanical systems. I think that idea, if you hear that, it is very clear, yeah, and absolutely makes sense. Yeah, since that time, since 40 years, people are working both on the theory and also in building real quantum computers, yeah, doing the physical implementation of that. And there are various approaches to that. So the next chart illustrates a bit again, the idea, yeah, and what Richard Feynman has described. So we can read the chart from left to right and also from right to left. So let's start with the direction from left to right. So if we, I mean, it says qubits, but that is not important at this time. So if you have a quantum mechanical system with a certain number of subsystems, yeah, that is the number here in this left-hand column. And then the right-hand column says, the system can be in various states, yeah, obviously. And the right-hand column says, how many traditional bits would you need on a traditional computer to express that state of the quantum mechanical system? If you have a smaller number of subsystems, you only need a moderate number of bits, yeah, on the traditional computer to express that state. But as soon as it goes beyond like 30, 40, or 50 or so, then we have this exponential growth. Yeah, we have that exponential growth from the beginning, but at like 40, it really hits us. And then obviously it becomes impossible to express, to store that state on the traditional computer. Yeah, because you would need more bits, yeah, in this example, than we have atoms on planet Earth. Yeah, and obviously it is impossible to build such a large traditional computer. Okay, so I mean, that illustrates the challenge that Feynman described. Yeah, if you have a quantum mechanical system, you need a huge traditional computer to simulate that, to express that. But now you can also read that chart in the other direction, yeah, and saying that if you have a traditional computer that stores a certain amount of information, then under very specific conditions, yeah, that does not hold in general, but for specific like problems, then you can express this amount of information with very few qubits, with very few quantum bits on a quantum computer. And again, as I said, that does not work for any like database with gigabytes or terabytes of data, only for very specific problems, but then it might work really, really well and lead to an exponential increase in speed, yeah, of the quantum computer versus the traditional computer. Okay, let's have a look at two examples, yeah, that illustrate a bit the potential and also the challenges with quantum computing. I mean, I just said that the speed up of a quantum computer only works for very specific problems, and we can see an example for that on the next two charts. So the first one actually does not look too promising. It shows how long it would take on a quantum computer and on a traditional computer to multiply two numbers. Yeah, p times q. It's two numbers, p and q, integer numbers with 2000 bits. And then on a traditional computer, I mean, that's what they do every day. Yeah, that takes a few milliseconds. And on a quantum computer, if you would have a quantum computer that is large enough, yeah, which we do not have today, but if we had, then on a quantum computer, there's an estimate that it would take 75 seconds. Yeah, so this is the decimal point here. It would take 75 seconds, but still orders of magnitude longer than on a traditional computer. And so if you just look at this example, then you would say, okay, maybe that idea does not work out in practice. But if we look at a similar problem, but not identical, then we can really see the potential and the speed up of quantum computers. Okay, so now we have a similar problem, but we do not want to multiply two numbers. We want to factor one large number. Yeah, so we have a 2000-bit number n, and want to derive the prime factors of that number. And I mean, you are aware that this is the core, yeah, of our typical asymmetrical encryption schemes. Yeah, and this takes very long on the traditional computer. And as it is stated here, that takes a couple of billion CPU years on a traditional computer. You have parallel systems with a couple of thousand CPUs, yeah, but still a few million of CPU years that are required for this factorization on a traditional computer. And now on a quantum computer, we have that algorithm that Peter Shaw found in 1994, which works very efficiently on a quantum computer. And if we have a large enough quantum computer, again, that will take on that machine around 8 hours, or could be done in 8 hours. And this now really shows the enormous potential and speed up that can be achieved with quantum computers for very specific problems, for very specific tasks. And now obviously the question is, are there any other problems, yeah, beside simulating quantum mechanical systems and factoring numbers that work efficiently on quantum computers? And that is being answered or discussed on the following chart. And this says, so we have the white area here, which are easy problems, yeah, that on the traditional computer can be calculated easily or efficiently. And then we have these problems like factoring, material science, quantum chemistry, which work efficiently, or which can work efficiently on a quantum computer. Yeah, that is the dark blue area here. And there's research and already algorithms known for machine learning and for specific optimization problems that also work very efficiently on quantum computers. Yeah. So these are also areas where we have high expectations once we have large enough and quantum computers with high quality. Okay, so let's have a brief look at the hardware. So this is the interior of a quantum computer. The actual quantum chip is located here at the bottom. And the whole system or the chip needs to be cooled down almost to absolute zero to work reliably and to avoid any noise and errors as good as possible. So this is inside of a cryostat. Yeah, the chandelier that we see here looks a bit like a chandelier, right? Has a diameter of let's say 60 centimeters and a vertical dimension of 1 meter. And on the right-hand side, you can see that we've already started to build larger refrigerators, larger cryostats for the next generation of quantum computers to scale them. I do not want to go too much into details of the hardware. There are different approaches to build them. At IBM, we are using superconducting qubits for that. Okay, a brief look at our development roadmap. And actually here in the lowest row, we can see the hardware development. And here we use the number of qubits as an indicator for the capacity of the systems. Actually, that is not everything that you need, not only the number of qubits, but also the quality of qubits is very important. And that is a focus area of current research and development to improve the quality of the qubits and reduce the effects of errors and noise. Okay, but I mean, that can also be measured, obviously. Here we just use the number of qubits, and currently the largest systems that we have, they have 65 qubits. Later this year, we want to move to 127, next year to more than 400, and in 2 years to a bit more than 1100 qubits. And at least in theory, when you add a single qubit to a quantum computer, that doubles the capacity of that system. So it's a huge step and a huge step forward, going from 65 to 1100 qubits in basically 2 years. Yeah, and with these systems, with the Condor chips, we expect that with them, we can, with the larger number of physical noisy qubits, we can like simulate or generate a significantly smaller number of error-corrected qubits, of logical qubits. And also the hope, the expectation is that with this, in this time frame, we will be able, as an industry, with these systems, to achieve quantum advantage for the first use cases. Yeah, we are not sure yet which use cases that will be, but we hope that by then we can run the first problems better, faster, cheaper on a quantum computer than on a traditional machine. Okay, and the roadmap includes much more than just the hardware, lots of things on the software side. It mentions Qiskit, yeah, which is the open source IBM quantum computing software framework. We will have a look at that a bit later. And many extensions, yeah, to Qiskit, improving the speed or the integration between the quantum and the classical side, also increasing the variety or the capabilities, the algorithmic concepts that can be implemented in quantum algorithms. Yeah, that is discussed here. I want to focus on a very specific aspect, and that is here on the enterprise developers. And our vision is, yeah, that it is called frictionless development. So we want to make quantum computers usable in a frictionless way, so that the application and enterprise developers can use them in their like normal environment, using their normal tools, their usual programming languages, and that quantum computers are fully integrated into that environment, and algorithms can be called just by calling an API, and then specific algorithms or parts of an algorithm that run efficiently on a quantum computer then will get executed on a quantum computer. Yeah, maybe a bit like the GPUs, graphics units that are used today, for specific parts of algorithms. Maybe we call it a QPU, a quantum processing unit, then, which will also accelerate specific parts of algorithms. I mean, that is the vision for the application or enterprise developers. Obviously, we also need additional types of developers that work much closer to the quantum hardware and really optimize how algorithms are implemented on the quantum systems. Yeah, that is indicated here. We call them quantum algorithm, and kernel developers. Okay, so that was the introduction. Maybe now is a good time to have a look at the polls. So the first one was, are you familiar with quantum computing? And around half of you said you've read some articles and like 25% understand the potential and the challenges which we have just recapped. Then, as we will use a Raspberry Pi later in this presentation, let's say half of you are somewhat or very familiar with Raspberry Pi, which is great. Then 3D printing is new to most of you. Only 20% have experience with 3D printing. And also 70% of from the audience are the first time at one of our developer events. Okay. So yeah, thanks a lot for answering these polls. That helps a lot in doing the presentation and gives a good overview and impression of the audience. Thanks a lot for that. Now the second part. Yeah, let's have a look at what can be done hands-on with a quantum computer. This chart actually mentions an article and the GitHub repository, and we will have a look at that live. And in the chat window, we will share the URLs both for the article and for the GitHub repository, and so you can have a look at that yourself after today's festival at your own pace and go through that in detail. Okay, so the article is called Hands-on Journey to Quantum Computing with IBM. It gives a short or some URLs for this more theoretical introduction. We can skip that. And then it mentions a quantum coin game as a first introduction. And actually this coin game uses a single qubit, so only one qubit. It introduces the effects of superposition and interference. So Miriam, I think you will share the URLs in the chat, right? And so that people have that available afterwards. Actually, this coin game is implemented or is available online as part of this Fun with Quantum GitHub repository. And let's have a look at that one now. Okay. I hope. Yes, so that was quick. So actually, the GitHub repository is called Fun with Quantum, and it should illustrate the power and beauty of quantum computing. There are several examples included there, which most of them use some serious games for quantum computing. Yeah, so some gaming, like a story around it. And typically, the rules of the game are set up in a way that with playing these games traditionally, with traditional rules on the traditional computer, you cannot win that game, or at least not with certainty. But if you modify the rules a bit, and allow some quantum moves, so to speak, then you can win that game with a certainty or with a very high probability. So there are several examples here. The first one is this quantum coin game. And if you scroll down a bit, then right here are these hotspots where you can launch that game, which is written in Qiskit, our Python-based quantum computing framework, on Binder, or on MyBinder. So that is a free service on the internet. And with that, you do not need to install Qiskit on your own system. You can just explore that web-based, as a first step. And if you get more interested, of course, you can install Qiskit on your own system then. Okay, brief walkthrough. So we have this coin game, which is only one qubit, introducing superposition and interference. Then there are two examples which want to highlight a bit what I have described as this frictionless development. So actually, these two examples around Boolean satisfiability problems, so ZAT or 3-ZAT problems, they do not go into the details of the implementation. They just show how easy it is to call a quantum program from a Python-based API. These are just like 10 lines, even less here. So I think it's 6 lines of code that you need to define the problem and then execute it on the quantum computer and then get the result back. So that is the intention of number 2 and 3 here. Then we have a bit more complicated game. It's called the GHZ game. It uses 3 qubits and highlights the effect of entanglement. Yeah. So which was described, or there was a comment from Einstein who said, so entanglement, that would be spooky action at a distance. Yeah, so that is a bit the relation. And this game uses entanglement and also describes it a bit. So number 4 is that GHZ game, that runs on this quantum computing simulator, so without errors and noise. And then number 5 investigates this game on a real quantum computer, and then discusses various error mitigation strategies, how you can control and mitigate the error to increase the winning probabilities also on a real quantum computer. And maybe as a quick preview, the end result here is that also on today's real quantum computers, which suffer from error and noise, you can reach a winning probability for this GHZ game on a quantum computer that is higher than on a traditional computer or with traditional algorithms. Okay, and then there are two other games. You're welcome to have a look at it. Okay, so that was the fun with an overview of this Fun with Quantum repository. Again, all the code is included here. Of course, you can see the Jupyter notebooks, the full source code here. And as I mentioned, you can execute them on MyBinder without installing Qiskit on your own system. And later, if you're interested, you can do that on your own system and install Qiskit and run that locally. Okay, so back to that Medium article. So we had a look at this coin game and the Fun with Quantum repository. Then the next step is a visualization of the Bloch sphere. So the Bloch sphere is a fundamental concept of quantum computing, and we will have a look at that in the third section and actually we can run this on the Raspberry. We will have a look at that then. Okay, and then the last part in this article is what is called what was called IBM Quantum Experience. Now it is called IBM Quantum Composer and IBM Quantum Lab. It is this URL here. We will also share that later in the chat window. You can log in there with an IBM ID, but also with various other types of IDs. And actually what we can, so let's first have a look at the different, it is called services, or we will go to systems. And that shows the real quantum computers that are available on the IBM cloud. And actually those without the lock, there's a number of systems that do not have the lock. Those without the lock are available to you to use for free. So you can run real quantum computing circuits, real experiments on real quantum computers, and also on a web-based simulator. Okay, now, and if you click on one of these systems, then you will get a very detailed information about that system. So this is the Casablanca, which has 7 qubits. This is the layout. It is called coupling map and indicates which qubits are connected to which other qubit. That is important when implementing algorithms. And you can also see various or a lot of very detailed information about the system. This is called coherence times, and also readout errors and other qubit errors. This data is updated daily when the systems are calibrated or recalibrated. So we actually publish very, very detailed information about these systems. And that is probably the reason why many research articles from other research institutions and universities are published based on the IBM systems, because you can get very, very low level access and control and very detailed information about these systems. Okay, so that was the first part, to understand what systems you have access to. Then as a first step, there's a quantum composer where you can like graphically build quantum computing circuits. Actually, I will skip that here at this point. We will have a look at that also when we look at the Raspberry Pi. Okay, and then there's also what is called a quantum lab. That is an online or a web-based environment where you can run, which runs actually a Jupyter Lab, yeah, and so Jupyter notebooks with Python, where you can program and implement your Qiskit algorithms and execute them. And it takes a moment to start up for that. And you will find that there are also tutorials included here. Yeah, so you can access the tutorials. There is one which is named Start Here, which is always a good idea. And in this tutorials, both the fundamentals of quantum computing, of Qiskit, yeah, and using the systems here are explained. Okay, I think we do not need to go into detail there. Right, then let's go back to the Medium article. We had a look at all this. And now let's have a look at the Qiskit website. Yeah, that is qiskit.org. And yeah, that is the site or the homepage for Qiskit, our open source quantum development framework. And I would like to specifically highlight the Qiskit textbook. That is a great resource. Let's go to the start page. So that is a great resource, a textbook, which describes the basics, the fundamentals of quantum computing, the state of qubits, multiple qubits. Then it introduces the well-known quantum computing algorithms, like also the Shor's algorithm, which we mentioned before, but also others. It has a chapter on specifically on real systems and how to handle and how to understand, how to work with these effects of errors and noise. It also includes a chapter on the code to run benchmarks on quantum computers. Yeah, and the result is called quantum volume. Yeah, so you can understand how quantum volume is measured and also execute that code. There are several labs which focus on using the real quantum computing systems. Yeah, so this Qiskit textbook is really a great resource. And actually, it is not a textbook, yeah, to print out and read, but it is interactive. Yeah, so you can work through that online, and there are interactive code elements, code cells included, which then gets executed in an online environment. Yes, so the Qiskit textbook really highly recommended as an introduction. And so it's not only the first introduction, it goes very deep, yeah, so you can really spend many, many hours with that. And also what we have seen, the qiskit.org website, it includes many other like sources of information. There's a Qiskit YouTube channel. There are many Qiskit like workshops, a hackathon, Qiskit challenge, which is about to start. And then also in this year and last year, we had a global Qiskit summer school, which had more than 4,000 participants this year and also last year. So that is really great, and yeah, very good feedback on that. Okay, so basically that is what I wanted to describe about this article, the hands-on journey. I mentioned also that repository, the Fun with Quantum repository. So that is what was described on these charts. Okay, so let's now move on to the last part of this session, the combination of quantum computing, a Raspberry Pi, and 3D printing. So what is this about? Actually, I think I have not yet shown a picture of our real quantum computer, with the housing and everything. So this on the lower picture on the right-hand side, that is a picture of the IBM Quantum System 1, as it is installed, for example, in Germany near Stuttgart, the Fraunhofer system, which was launched in June this year. The physical dimensions are like 3 meters wide and similar height and depth. Okay, and now the idea was to build a model of that real quantum computer system. And so I can show that briefly, but we will focus on the chart first. So we have designed, and that was done by André, who really did a great job in 3D modeling, so that you could print out with a 3D printer a small model of this IBM Quantum System 1, which we can see up here. But we did not want to have just a 3D model, but we wanted to have a functional model. So now what does that mean? Actually, we integrated a Raspberry Pi mini computer. I hope you can see the Raspberry Pi mini computer inside of this 3D printed model. And actually on that Raspberry Pi, you can install Qiskit. And Qiskit includes quantum computing simulator. So locally, in that 3D model, you can run quantum computing circuits, and you can use that to access the real quantum computers on the cloud. So let me pause for a second. I will dim the window here so that the light does not disturb. Okay, so apologies for that. I hope that is better now. Okay, so on the next chart, these 3 components are described again. So it is based on Qiskit, on a Raspberry Pi mini computer, which I have shown, and a 3D printed housing. Okay, so and instead of looking at the next chart with various pictures, let's have a look at the real system. Okay, so we can switch the video mode now, I think. So this is the system, so you get an impression of how big it is. And then the Raspberry Pi, that is here in the back of the model, actually. And we have also integrated a touch screen, that is a 4-inch touch screen, which you can use to control. I think that is good. Which you can use to control the system, to start various demos, which we will do in a second, and also to display the results of the quantum circuits, obviously. Okay, we have a glass housing, a laser engraved logo. You can. There are many ideas how to extend and how to add additional elements to that model. Okay, so I will now use the touchscreen here at the back to start the first demo. That one is called Lights, and as you can see, there are LEDs integrated into the cryostat, and they kind of show. Sorry, I was a bit irritated because it should be more LEDs, so that was changed in an update that I did. Actually, we have 65 LEDs integrated here, so it could run down here. And now the demo that we see now, it just fancy lights, but it does not has no quantum mechanical or quantum computing meaning. But there's a different demo on there, which is called RustQLED. I will start that one now. And that one actually creates a quantum circuit, applies superposition or creates a superposition. Right, so now you can see all 65 LEDs. this creates a superposition, on each of these of the qubits, which are then displayed by each of the LEDs. And then in the next step, it creates not only superposition, but also entanglement of a certain group of qubits. So we have 65, and in the first step, we always have 5 qubits entangled. So always 5 consecutive qubits show the same result or are in the same state. And next, we have 13 qubits who are entangled. And as a last step, 65 entangled, so that we see the same color on all of these. And actually, blue, I think, represents the measurement of 1, and red represents the measurement result of 0. Okay, so let's stop that. Okay, so and now I would like to show 2 other demos, and that is better if we use VNC and have a look at the display. Right, so that is great. So actually what we see here, that is a VNC connection to the Raspberry model that we have seen. So this is exactly what's on the 4-inch display on the back. Okay, now let's have a look at this Blochsphere demo, which I briefly mentioned when we had a look at this Medium article. And so we can run locally an interactive visualization of a Blochsphere, and the Blochsphere is a, let's say, physical or mathematical model of a single qubit. And it indicates the state of a single qubit, and how you can manipulate, how you can apply gates to that single qubit. So we start here in the state 0, and with an X gate, we can, which is also called a NOT gate, we can move it to the 1 state. So that is not different from traditional computing. But if we go back to 0, we can also apply a Hadamard gate, which now puts this qubit into a superposition, into a linear combination of 0 and 1, which is one of the effects that only exist in quantum mechanics and in quantum computers. Right, and as you have already seen, you can use the mouse or the touch display now to turn this Blochsphere around and have a look at it from all directions, from all angles. And there are some additional gates that you can apply and try out. And up here, that is the mathematical representation, the formal representation of this quantum state that we have here. Good, we will leave that demo and now have a look at the Quantum Composer, which is a part of that IBM Quantum website, which we had a look at earlier. And I mean, this now also runs on that small display, but we need to clean up this a bit. So we can do that here better, because 4-inch is not too much real estate to have everything on here. Okay, now we can also collapse the gates. Right, and now we can create quantum circuits. So we have, by default, we have 3 qubits here, but we can add additional ones or remove ones. Yeah, I mean, let's start maybe with a NOT gate. Right, so that is already the first quantum circuit, but maybe do it a bit more interesting. We can use the Hadamard gate and then a control NOT gate, for example. And now we have created one of the famous quantum states, which is called a Bell state. So we have created a superposition, and with this gate, which is called control NOT, we have created entanglement. So I realize that does not look too spectacular, but actually that is really the source of the power of quantum computers. And if you combine that in the right way with longer algorithms, with longer circuits and more qubits, then this really constitutes the power and the speed up of quantum computing. And using with this graphical interface and the other things that I have introduced that can help, I think, a lot in making the first steps into quantum computing, understanding how it works, and really try it out hands-on. Then you can move on to the algorithms and use cases, and then really understand how can it apply to various industries, and also what are the challenges that still need to be solved. Okay, we can exit this demo. And then maybe the last thing, or one thing that I would like to show is the configuration menu. And it is called, the script is called RusQ-init. And that can be used, it looks very similar to the Raspberry config. Sorry, it's called RusP-config, I think. That is the standard configuration tool of a Raspberry Pi, and we've modified that, called it now RusQ-berry config. And that can be used to do the basic installation of the RusQ-berry, to install Qiskit. You can select various different versions to install the quantum computing demos, configure this in a way that this Blocksphere demo, for example, automatically starts after each reboot, and so on. Okay. So at this point, maybe let's have a look at the GitHub page, because RusQ-berry, that's an open source project, and everything that you need to build such a model yourself, including all of the code, the install scripts, full documentation, of course, the files that are needed for a 3D printer to print these models, everything is available on GitHub. The shortest URL is rusqberry.org. We will also post that in the chat. You will get to exactly this page that we see here. And that includes a high-level overview, the documentation, which we have here, of course, also a link to the 3D files. Again, Andrei Balishev, he created that model, and so that was really great. Yeah, I'm really amazed how he did that, and how solid the model is. Yeah, but also focus was on that it can be printed easily on a standard, on a home 3D printer. Yeah, I mean, I have a 3D printer which costs like 300 euros. And that is good enough to print that. Yeah, but there are also 3D printing services on the internet where you can have that printed for you. It shows a bill of material, so with the touch display and all the other elements that you need or that you could put into the model. Build instructions, description and usage instructions for the demos. And there's also a brief description of how you could contribute to the RusQ-berry open source project. That would be really great, if some of you are interested in that, build it yourself. You can use it just with a Raspberry Pi without the 3D printed housing, or with the 3D printed housing and the touch display and so on. If you submit issues, if you see something is not perfect there, definitely there are things, I know that very well. Or if you have ideas what additional demos could be integrated into that model, and can be implemented in a way that it can be used on this 4-inch touch display. So we are very interested in additional quantum computing demos, definitely. Okay, and then there's a quick installation guide. And actually, these 3 commands that we see here, the pip install, then calling the script, downloading this RusQ-init script, and then starting the RusQ-init script, that is everything that is needed to get started with RusQ-berry once you have access to a default install of a Raspberry Pi. So you just install the Raspberry Pi OS, then use these 3 commands. And then you can use the menu system, as we have seen, to set up, to install Qiskit and install the demos and so on. All right. So I think that is what I wanted to show and what I wanted to discuss. Again, this is the URL, so http raspberry.org. That gets you to the GitHub page. Very interested in your feedback, in your comments. If there are any issues, please open an issue in GitHub. And this is the URL for the Medium article, which we had a look at. Okay, so with that, thanks a lot. And Miriam, if there are any questions or comments, happy to discuss.
Yes, thank you so much, Jan Reiner. We do have some questions, and I really just thank you so much for your talk. It really embodies our focus and passion on open source. And like you said, Qiskit is an open source development framework for working with quantum computers. It's a wonderful community. It's really busy, and you can build quantum applications and experiments with Qiskit in an IBM Cloud programming environment. So that's just perfect for the start of our developer festival. Thank you everybody for your questions and comments. The most voted question is from Shivansh. Can we get this presentation? Jan, please, can you just send it over to me and we'll share it with our audience for sure.
Yes, definitely. We can share that. I think the most important aspects are the URLs to that Medium article, Hands-on Journey to Quantum Computing, and the Raspberry GitHub page. Yeah, but we can also share additional charts. I'll send it to you. Sure.
Great, thank you. And a similar question from Bartosz is, will this session be recorded? I should have mentioned that at the start. My apologies. Thank you for asking and reminding me. Yes, all these sessions of the Developer Festival are being recorded. You will be able to watch them later. And will we send them to the participants? Yes, we can send an email after each day of the Developer Festival with the link to the recording. In fact, when the live stream has ended, you can hit refresh and watch it all over again. So it's available seconds after the broadcast ends. We have another question from Sebastian. This one's for you, Jan Reiner. Are there real-world cases for quantum yet, or is it all research and development?
Yeah, so I would say it is both. Yeah, I mean, I mentioned that in the industry we did not achieve quantum advantage yet. Yeah, so there is no practically relevant use case today. Yeah, where a quantum computer is better, faster, cheaper than a traditional computer. As I mentioned, we hope to achieve that with the Condor systems in 2023. Not sure for which use cases that will be achieved first. But so there's a lot of research to do. Yes, definitely. On the other hand, there's a lot of research also done on the use cases. There exists quite a number of implementations already for industry-specific use cases here, how to map them to quantum algorithms that can then be executed on the quantum computers, on the simulator or on the real systems. Actually, because the systems are quite small today, yeah, you can only run very small instances of these problems on the real quantum computers. That will increase obviously over time when the systems get larger. So today, yes, there exists concepts, yeah, how to implement real use cases from finance, travel and transport and others, how to map that to quantum algorithms, how to implement that, and it can be executed only for small problem instances today. Yeah, I hope that answers the question, so puts that a bit in perspective.
Thank you, that's great. And we have another question from Hayo. Could the demos be used without the model?
Yes, absolutely. I mean, the core that you need is a Raspberry Pi. On that Raspberry, I mean, you can access that, as I did in the presentation, with a remote connection using VNC. Yeah, and then you do not need that 4-inch display in that model. And the rest, and also not the 3D printed housing, yeah, which just looks nice, but has no function in that sense. Right. So you can run the demos just using a Raspberry Pi. I mean, of course, the LEDs, yeah, then you don't have that, yeah, but that's not mandatory, that's not required. And I mean, to be fully honest and transparent, you can also install Qiskit on your laptop, of course, yeah, and run these demos on your laptop, yeah. But we thought it is just a nice combination, yeah, and very, very interesting that you can run Qiskit and the quantum computing simulator on a Raspberry Pi, yeah. And also, I mean, this is like let's call it a virtual or a development environment, so that you do not need to install it on your production or on your main laptop, yeah, if you prefer to have that separate.
Great, thank you. Another question is, can the superposition and entanglement operations be used to do linear algebra operations? And if so, is it faster with quantum than conventional computing?
Yes. Yeah, excellent question. And absolutely. So everything, the whole theory behind quantum computing that can be fully expressed with linear algebra. Yeah, it's just matrix vector multiplication, yeah, with complex matrices. And the challenge is, so I mean, why is it so complicated? Yeah, going back to the idea from Richard Feynman, why is it so complicated? Also, why doesn't it so much effort to simulate quantum mechanics on traditional computers? That is just because these matrices get so large. Yeah, the dimension is 2 to the power of n, where n is the number of qubits or of subsystems in that quantum mechanical system. And that gets really large, yeah, if you go with n above like 40 or 50. So that basically what a quantum computer does in that sense is not complicated, yeah. It is just handling these huge matrices in a very efficient way. So then, I mean, the idea basically that you describe is, I mean, can we do arbitrary linear algebra operations with a quantum computer more efficiently than with traditional computers? The answer is not any, or yes, so not arbitrary linear algebra, but only very specific tasks will run efficiently on a quantum computer. And that is a bit similar to what we have seen with the multiplication or factorization of numbers. Yeah, some problems are very well suited for quantum computers and others are not.
Great, thank you for that. And thank you, Grace, for asking the question. We have any more questions? I'm just scrolling through. We didn't need a Raspberry Pi for this event. We've shared the link to the article in the chat, and we'll share it after today's live stream as well. There is a question from Youssef, don't you need to sign in to have access to the IBM quantum computer? And we've got the link at the bottom of your live stream in that green button there. We've also got some questions specifically about the Raspberry. Where can we buy the hardware components to build Raspberry?
Right, so these are all standard components. Yeah, I mean, the Raspberry, so currently the supply is a bit limited, yeah, but if you wait a couple of weeks, I think the containers from Asia will arrive again. And so that is a standard component. There are many vendors for that, or many shops where you can buy that. The other elements that are listed in the bill of material, they are also standard and various sources to buy them. Right, I do not want to recommend a specific vendor. Really, there are various sources for that. You can find the cheapest one, and it should not be difficult to find a source for that.
Okay, great, thanks. Is there a Docker container available to play with it without running the whole Pi only as Q? Another question from Hayo.
Yes. So I would assume that yes, there are Docker containers with Qiskit, but we so as part of the Raspberry project, we have not created a Docker container.
Okay, thanks. And final question, what is the significance of connected qubits as we see in Qubit Map on quantum computing IBM.com?
Yes.
That's a specific...
That's also a great question. So what we have seen from, what we have seen in one of the circuits that we have created is that you can apply these quantum gates, these operations on a quantum computer, not only on a single qubit, but also on 2 or multiple qubits. So I wanted to show that here in the circuit composer, but I think that takes a bit longer. So you can, there are specific quantum gates, yeah, that are applied to 2 or even more qubits. And for that to work, these qubits, these 2 qubits need to be connected on that coupling map that we have seen. Yeah? And so that means you have no any-to-any connectivity, and that means that you can only apply these 2 qubit gates to a specific combination of qubit and not to all. There is like a kind of a workaround. You can swap qubits. Yeah, you can exchange them, and so you can reorder them so that you have them in the right place, and then apply this 2 qubit gate. But the downside of that is that when you use these swap operations, these are additional operations that are executed, and so your circuit, your program gets longer, and then has a higher effects of noise and error. Yeah, so in general, you would try to use as few gates as possible. Yeah.
Great, thank you very much. There are a couple more questions. I would be really, I would appreciate it if you did take a look in the chat, Jan Reiner, in the ask a question section, sorry. And there's a couple of things that I can do there, but if you could take a look for some of the other ones, that would be great, much appreciated. Thank you so much for opening up our developer festival, and with what a way to start with such a great topic. And yes, we'll be following up with all the information, all those wonderful resources and links after today's session. And the chat is also filled with praise for your session. Thank you so much for joining us. And we'll hope to see you again soon. Great, thank you. And our next session is how to automate your infrastructure deployment with Pedro Luis Perez. So I'm just going to check. Yes, thank you for posting the link. We have a feedback link, which you can see in the chat. It's ibm.biz and it starts with a B. And you can click on that. You can share your feedback with us in just 3 clicks. That's as easy as it is. And I see now Pedro has joined us. Wonderful. Hello, Pedro.
Hi, good afternoon, Miriam. Can you hear me well?
Yes, perfectly. Wonderful. Welcome. Welcome to the Developer Festival.
Thank you. It's a really pleasure to be here.
Super. And I'm sharing my screen. I'll stop sharing. And I would love to hand it over to you. It's wonderful that you're joining us. Maybe, yeah, you would like to introduce yourself with a couple of words?
Yeah, sure. My name is Pedro Luis Perez. I'm from Spain, and I've been working at IBM for 2 years. It was after studying a master's degree in big data, and before that, my background is industrial engineering. My current position is cloud engineer on the IBM Spanish Cloud Engineering Department, formerly known as Tech Garage. If you don't know what is IBM Garage or Cloud Engineering now, what we do is to bring a more startup kind of creative style to the tradition company. through enterprise design thinking in each squad, we are able to develop MVPs from start to finish, and in an accelerated way with the most cutting-edge technology, such as cloud computing, what we're going to talk about today. And just for finishing, as cloud engineers, we design, create, and maintain the cloud infrastructures on which the most disruptive solutions will be developed for our customers. More or less, I think you can have more or less an idea of what I do here and what we do in IBM.
Yeah, thank you so much. That's really insightful to know a bit more about you and your journey at IBM and what you're doing now. Very exciting.
Thank you for inviting me.
Sure, we're really glad you're joining us. And we've done a technical check beforehand. Do you want to be sharing your screen today?
Sure, let me check if I am able to.
Switch mine off.
Sure. Okay, I think it's here. Okay. You should now see my screen.
Yes, that looks wonderful.
Thank you. Okay, so today we are going to talk about standardization and automation. We're going to cover a couple of interesting concepts before presenting our solution we are developing. But first, I want to start with a bit of history. Miriam, does he look familiar to you? I think he shouldn't.
I'm racking my brains. I don't recognize him from the others.
What a relief! What a relief! It's a historical person, but I think if it is not your field expertise, it would be a bit strange that you could recognize him through a portrait. So, well, he is Eli Whitney, an American inventor and a gunsmith of the 18th century. Perhaps you do know the second character in our story.
I don't think American history is my expertise.
A clue, I think his face appears in the dollars money, in the dollars notes, and he is Thomas Jefferson, the third president of the United States of America. Well, which kind of agreement could join these two men? Well, the answer is a contract to manufacture 10,000 of muskets in 2 years. It could be threatening. So, the point is that it seems that Eli Whitney did not comply with the contract after the end of the period, so he was called to the Capitol to clarify the situation. What did Eli Whitney do? Well, Whitney brought with him a box of containing the complete parts for 10 muskets. First, he arranged the equal pieces in stacks before the eyes of the congressmen witnessing the performance, and after that, Whitney asked several congressmen to take a random piece of each stack and finally assemble a musket. Repeating the process with all the 10 random parts, 10 muskets were perfectly assembled. The performance earned Whitney widespread renown and renewal federal support. I would like to do a disclaimer here, and it is that I consider myself a pacifist, but I am always against any kind of war or bellicist conflict. But this is the first known case of standardization in history. So today, as we said before, we have come here to talk about standardization. Sorry, my throat is a little sore. With standardization, we expect reuse of the parts, intangible parts, homogenization of the results, and time saving and error reduction. So now, yes, come back to the beginning. After this introduction, I want to talk about standardization and automation. And as I said before, we are going to introduce quickly two concepts: infrastructure as code and GitOps. The first term regards infrastructure management. Manage IT infrastructure range from physical equipment such as bare metal servers to virtual machines or cloud services and their associated configuration resources. Also, we have to a declarative approach. Sorry, which means that a desired state can be defined as code. These definitions can be hosted in a version control system and like GitHub, GitLab, or something like that. Both scripts and declarative definitions are user rather than manual process. So we have this, and we have the second. Oh yes, we have infrastructure as a code as a declarative methodology in which by code we can define the desired state of course following rules and languages. And the system will try to achieve and maintain this desired state. What we do for that is we use Terraform. We are in an IBM event, and Terraform is not a particular IBM tool. Actually, it is Cloud Cross. Indeed, it is used in Amazon Web Services, Google Cloud, and Microsoft Azure Cloud. For example, I'm pretty sure that a lot of people from here will know Cloud Packs, and we can offer Cloud Packs directly on our IBM Cloud. And the installation, the managed installation, the underlying process which allows this automatic installation is Terraform running with IBM schematics. So this is the first term, and now we are going to follow to the second, that is GitOps. I'm pretty sure that a lot of you are also familiarized with this term. Well, the philosophy is that if it is not in Git, it shouldn't be deployed, and if it is in, it should be deployed at the same state that Git indicates. Well, what it allows to us? This allows to us to have a mechanism to have versionate, creation, elimination, and modification of any object that makes up the infrastructure. An agent will oversee checking the repo for changes and will control the system is in the state that it is requested in Git. So we are developing this operator. I would like to say here that it is not a project that my colleagues and we have been developed from scratch. It is the result of refactoring, simplifying, and humbly trying to improve previous projects. With this, we're able to create a continuous integration and continuous delivery cloud architecture with one click, thanks to IBM Toolchain, continuous delivery, GitHub Enterprise integration, and IBM delivery pipeline, and also IBM schematics. That what we have said before, it is the way we have to use Terraform on our IBM cloud. Everything our project is stored in a GitHub repo, and I think Miriam is going to provide you the URL for this project. We are going to provide you a public URL, and please feel free to comment, to transfer us any comment, anything you need to let us know. Maybe we can improve, whatever. We are happy to listen, whatever. Okay, this is the structure of the project. It is divided in 3 folders. We have Bluemix, schematics, and Terraform, and then we have the flow that all the process occurs when we launch this tool. The point is, we have these 3 folders. The first one is .bluemix, a hidden folder. This structure is guided by the Terraform guidelines, and what we have in the first folder, we contain the IBM Cloud particularities for the CI/CD pipelines. Then we have schematics, where we have a JSON. We can see that we have all plain text. We have YAMLs, we have JSONs, and we have TF files, and these are the Terraform files, but everything is just plain text. In the schematic, we have in the schematics folder with the initial JSON file, we have all the specification for our projects. And for last, the Terraform folder, in which we have more IBM Cloud settings and another variable file and the service-specific files. The flows is we have everything here. It is outside of our GitHub Enterprise repository. Everything occurs inside IBM Cloud, and the cool part of all this is that you can trigger the system just with an URL and a couple of clicks. This is the URL, and everything starts to work out. Okay. As prerequisites, we need an IBM Cloud account with administrator permissions, GitHub accounts in which we can fork or clone the repository, and of course we have all the credentials to be able to work with that. And we can even use with GitLab too. For this tutorial, for this asset, we have used GitHub, indeed Enterprise GitHub, and we have the structure here that we have already explained, and we have also mentioned that all the trigger is an URL, and in order to make this URL, we have defined it in several points in our README, but as you can see, there is a few variables we have to fill in, such as the region in which IBM Cloud we are going to deploy, if we are going to use, for example, a Kubernetes or an OpenShift cluster, we have to specify a bit more details, the repository of the GitHub that we are going to use, the branch of the repository, and then the credentials. I have to please remind me that I have to renew my credentials after this demo. And we have another components that it's going to be the toolchain name that we are going to use in IBM Cloud, our Git provider, and a few of more variables. Okay, and we have also here, after launch this URL, we are going to see that how everything is already filled, and we have just to create, and the process starts, and all the pipelines are running, and it should, if we don't commit any mistake, it should run automatically. I think that cool part of all this is trying to show it with a demo, and let's hope the gods of the demos are on our side today. So we have here, I think you still can see now my Visual Code Studio. Please, maybe Miriam, you could confirm me that we are seeing the Visual Studio, or we are still.
Hi, we're seeing the presentation at the moment.
Okay, maybe I have to change it. Let me check one sec. Oh, no, I think it is already we are watching the Visual Studio Code.
Okay, I'm seeing in the comments everyone can see it, just I can't. That's interesting. I'm going to try and refresh my browser.
Okay.
It seems from the audience we're good to go.
Okay, we're good to go. Perfect. Well, it is what we do in the client engineering department is we have this template, and we fork this repository to personalize it to each project, what we work on it, and what we are gonna do to deploy a very quick case. We are just going to deploy a Watson Studio. If somebody of the audience don't know, Watson Studio is our platform to as a service to develop machine learning and artificial intelligence projects, and this is the only service that we are going to deploy for now. We have the Bluemix folder with a bunch of files. Then we have the schematics with the initial JSON, and this is where all the variables we are going to put on it we have to modify this JSON file, and then we have our Terraform folder, and we have in these files we have the main file in which we are going to specify if we are going to develop, if we are going to deploy any cluster, OpenShift cluster, Kubernetes cluster. We have another file with about the provider with IBM Cloud information, and then we have another IBM Cloud particularities, like for example the resource group, and okay, and then we have the another variables in which file in which we declare all the variables. For last, we have here just one Watson Studio file, our service file, and we have it here with, for example, the plan, the different plan we have, the plan light, the plan premium. We are going to use light plan in this case, the region we want to deploy, and another, the name, what it has, it's going to have the service and these kind of things. Okay.
Pedro, maybe could you zoom in just a little bit? I can see it all well,
Sure.
but that's great. Oh, wow, that's perfect. Thank you.
Okay, I think we can launch our tool, and maybe we can come back to the code again, because the process has it takes some time. So I have prepared here some. Let me just clarify if we are logging. Okay, it seems we are logging. Perfect. We have here the repo with the flow and the of the schema of the repo, and I have several services here, but I have filtered with the default resource group. And okay, let's gonna try to let me check one sec. Okay, okay, as I mentioned before, we have to compound this with an URL, and I have already filled it here. And what I have done here is remove the line spaces. So I think we are ready to copy this and launch it here. Okay. Okay, as I said before, we have here already the toolchain name. It is specified here in the URL. We have to choose the default resource group, and the rest should be already taken from the URL, the region we're going to deploy. The GitHub repo, he's taking all the information. He's trying to more settings we have already bring it to the system, the owner, and also the delivery pipeline. It has correctly taking my IBM Cloud API, and I think we are ready to launch it. Okay, so let's gonna create. Finger crossed. Okay, here we go. It seems it's everything all right. Okay, now let's gonna open this in a new tab. Okay, now if you are familiarized with Terraform, in order to segment your work and to correctly monitorize all the processes you are trying to carry on, we have been separate our processing in 4 phases. We have the creation of the update of the schematic workspace. As a reminder, schematics is the way that we have here in IBM Cloud to run Terraform. After that, let me check. Oops, sorry. Let me check one sec. A problem occurred. I don't like that. Oops. Let's see if it is just a problem with my browser or... Okay, let me check. Okay, I think it should be running. Is something just... Okay, here we are. Okay, meanwhile we were trying to upload the browser. It seems that we have already passed the first phase, in which we have created our schematic workspaces. Now we are in the refresh stage, in which we don't want to change everything anytime we are going to commit any changes. Just we want to apply the changes for each commit, sorry. And we can also try to monitorize a bit more this phase, and we have the logs. So okay, we have here, and okay, already passed the second stage. It seems that it is working. Okay, we have now another phase running. This is the plan running in this phase, in this stage. What schematics is planning all the changes that we are going to apply. As I said before, if we have had already a services that it hasn't changed in the code. It's not gonna reapply. It's not gonna destroy and recreate it. So it's gonna just leave it in the desired state. So and I think I have here another log, and we can see everything what we are doing here with Terraform. It is shell scripting. If you know Linux, you can manage perfectly with that. Here at IBM Garage, we now client engineer. What we try is to be as smarter as we can. So anything that we can reuse, all the code, all the tools, all the assets, if we can reuse and put our effort in create new value, we're gonna. This is what we are gonna do. So this is the reason we have created this tool, because we can reutilize this, reuse this in a lot of projects. Okay, now we are in the last stage, and it seems that it is working. We have seen here that we have already, let me update this browser. We have here this diff test toolchain test. This is the how do you say that? And this is one of the part of our CI/CD system, and we have also here the diff test. We have the schematics workshop, in which all these Terraform scripts are running. If everything is going okay, at the end of this stage, we should see here develop our service. I think I have to filter it here in order to don't just to visualize our service we are developing. We can check here that what we have done is just use the URL, compound the URL that we have here, URL, and after launch it, it already appears the toolchain creation and start all the flow, all the system. Also, it creates a resource group that it's the way we have here in IBM Cloud to containerize our solutions in order to delimitate perfectly the cost of the solution, if it has any cost. Okay, and I think it is already done. Okay, let me check. Okay, let me filter with dev test. Okay, so here we have our Watson Studio, and it should be up and running. Okay, in less than 10 minutes, we have our service that we have defined here in the code with this TF file, and launching this, we have a CI/CD system in which we can leverage to deploy our infrastructure. We understand here our infrastructure as resources that we have deployed here in IBM Cloud. It could be software as a service, or it could be also infrastructure. I don't know if is there any doubt or any question for now? Or in order, I have another phase in another stage in our demo I want to show you. Maybe we have any question we can answer by the moment.
Great, thank you so much, Pedro. There is a question for you in Ask a Question, and to the audience, a reminder, you can put your questions there at any time and in the chat. So the question is from Max Simon, and it is, can you explain the difference or advantages comparing the operator to Argo CD?
Okay. We are using this IBM Cloud tool in order to deploy and managing all the IT infrastructure regarding IBM Cloud. This is a live project. It is already developed. I think it will be, I mean, it is a live project. It's gonna be constantly improving. And we have a second phase of this project that it is including Argo CD for Red Hat OpenShift clustering. But it is this Argo CD tool is we are gonna just use it in the cases that we develop an OpenShift clusters. And we have to explore too also if we can use Argo CD for another cases too, but this is the only case we are now considering, and it is in our pipeline of improvement of this asset. Is there any question, or maybe I can move on to the next part of the demo?
There is one more question.
Sure.
You can answer it at the end if you prefer. What's the difference between Ansible and Terraform, please? This question's from Rochana.
Well, Ansible, as far as I know, is part of the Red Hat portfolio, same as OpenShift or another solutions, and it is also related with automation of infrastructure. Actually, I think, as far as I know, is also cloud infrastructure. Here with Terraform, we can automatize more things, like, for example, software as a service that we have in our IBM Cloud particularities. As far as I know, they are not antagonists, they are also compatible. But what we use is here Terraform by schematics, because not always, and the same case as before, not always we are going to use Red Hat solutions for our projects. Okay, I think we can maybe move on to the next part of the demo, and maybe we can come back to the questions. I have presented this solution as CI/CD solution. I mean, continuous integration, continuous development. I want to show it now, and what I'm gonna do is I have here I have here the project, and what I'm gonna do is, for example, Watson Studio, as I said before, is a platform for artificial intelligence development, solution. So what we are gonna do is adding a service to Watson Studio. For this demo, I think we can use, for example, a Watson Assistant. It is one of our greatest project solutions in order to develop virtual assistants, and we are going to just drag and drop the Watson Assistant TF file from non-deployable folder. It's the way we have choose to keep all these services non-deployed. It is simple keys, and what we are gonna do is just drag and drop here to the main folder. Now the Git has, I'm gonna minimize this. So if I now use my Git to check if is there any changes, we have seen that we have a new file, So I'm gonna put it a bit bigger, okay? So what we're gonna do is add this file, okay, and I'm going to commit a new change. Okay, and now, okay, now we have here the log, and the status is that we are locally ahead one from the repository. So if I push this change, okay, if everything is all right, without doing anything, the schematic should listen this change and start automatically the process again. Okay, please, gods of the demo, tell me that everything is all right. Okay, it seems that we have an issue here. Everything couldn't be. Okay, let me check. Okay, it seems that there is any issue with the schematics and it is not running. I have a video here. Oh, it has already started. Oof, what a relief. Okay, we can see here my last commit. I swear I haven't do any magic trick or anything. It's just something listening in our delivery pipeline and the continuous delivery system are listening to the changes to my repo, and it start the process again. It should take a bit less than before because all the services that allows this this system, this tool are already up and running. And let's gonna check we can also check the logs than before. Okay. Okay, first stage has already passed. Let's see the second one. Okay. The refreshing stage is checking that which changes is comparing the desired state that we have declared in our repo with the current workspace schematics from schematics in which is also define our solution. Oops, something has not working well here. Let me check what's happening. Time taking. It seems it has been a problem with the system. I'm gonna relaunch just this stage. Cross my finger to see if it works. And I can see that we have to update this schema because with the original phase of this asset, we had like 3 just stages, and now we have 4. We have to upgrade this schema. Okay, finger crossed. fail again. I'm sorry. I have prepared here a video in which I have the same process that I have recorded. You can see, and this is the first run. I'm so sorry for, I don't know which, and I think it's not interesting for you. Check the log and see which is the problem, but here it was the first time that the pipeline has run, and we have here the Watson Studio, and I have recorded here how also dragging and dropping the Watson Studio, the Watson Assistant. Oh, maybe I think I know what can be. This is the part. Okay. If I come back to my code, this is the problem. Okay. The thing is that as I said before, this is the template. It is a template, and we have already prepared the bindings of our cloud services to in order to connect them with the Kubernetes or the OpenShift cluster, thinking in the next phase, in the next stage of the project. So, okay, I'm going to comment this because it is just the way we connect to our Kubernetes service. You can see here, and let me see. Git. Oh, I have to save it first. Okay, Git S. Okay. Fixing Watson Assistant bindings or TF. Okay, and git push. Now we have to wait again the next again to start. Okay, it is starting over again all the schematics process, and we can just wait until it is already done again. Miriam, maybe is there another question? Maybe we can start to answering.
Super. Yes. Thank you. I thought with everything green, it looked wonderful at the start, and glad that the demo gods were with you at the start. Okay, so questions. We have got a few. Let me just get one. Okay, so how is IBM schematics different from Terraform?
Okay, I'm not a very, I'm not expert in order to, I'm not a sole person which is going to sell you well schematics. The thing I can say is that as far as I understand it, is schematics is another layer to Terraform. It's the way that we encapsulate the Terraform scripting in order to run it on our IBM cloud. It could be an analogy that OpenShift is as to Kubernetes, same as schematics is to Terraform. I'm not sure if I have already answered the question well, or even I have produced more complexity to this, but I think it's something like that.
Thank you. That sounds great. And we have got another question from, so that question was from Russ. Thank you, Russ, for that question. From Cedric, we have the question, if I want to do the deployment on-premise, so a physical server, is it better to use different technologies? The suggestion from Cedric is Ansible and Terraform.
Well, this asset is thought to deploy different services on our IBM cloud, and Again, I'm not an expert, but we have IBM Cloud Satellite, and it is the way that we can allocate our our IBM Cloud to different environments. For example, on-premise. I'm not sure if it is already general availability or to general availability to different services. I'm pretty sure that you can use satellite to deploy OpenShift clusters and a few databases, and should be perfectly compatible to deploy IBM Cloud Services to Ansible, to satellite locations. But I think it is still in a early stage of developing the IBM Cloud Satellite, so I cannot assure, but theoretically it could be perfectly suitable for this task.
Great, thank you. Yeah, I've put a link to Cloud Satellite in the chat to check out because it's a really, really exciting technology from our teams here at IBM, and yeah, it's up and running. They had the GA already, I believe, and yeah, definitely worth checking out. You're more than welcome. Both Russ and Cedric say thank you for answering their questions. And I think that's all the questions for now.
Okay. Meanwhile, you were transcribing the questions, and we have passed the second stage. Woo! What a relief! And thank you to the previous record, we could easily check the where was the problem, and now we are on the final stage. So soon we should have here our Watson Studio. Our Watson assistant. I think that the key point of all this project is the ability to reuse all these assets, not all these projects. Why? We are always thinking just not in developing MVPs. We want these MVPs, they can scale up. So one way to support that or to provide value to that is if we design our infrastructure as a code, we can easily replicate in different environments, in different systems, and or even changing a bit the code, we can reuse and reutilize this in different customers. Now we have refreshed the browser, and we have also here our Watson assistant. As we can see, we have defined a region, we have defined resource groups, and everything is up and running. So I think it's quite interesting. We can also maybe remove the process to remove an asset should be the same. Just remove our service here. For example, I'm going to remove this to this non-deployable, or just delete the and delete the file, and push here the code again, and it should delete the service. We can also, for example, change here the plan, or we should change this in the initial JSON. We could look for Studio, and let me see Studio, and we could change, for example, the plan for free to a premium plan, and it could roll up. It could develop directly. The same with the infrastructure machines. For example, if we want a cluster, a minimum cluster to start developing on of Kubernetes or OpenShift, and we want after that a more powerful compute potential, we can easily scale up using the code. I think it's quite powerful. I think it's so useful, and this is the asset we are working on it.
Great, thank you so much. We have got a couple of general questions.
Sure.
So there are some, shout out to the audience. If you have any specific questions for Pedro, please let us know in the chat or in the Ask a Question. Just in case you've joined us in between, this is being recorded. Yes, you will be able to watch this all over again. The whole Developer Festival is being recorded, and we'll share the replays with you afterwards. So no worries if you missed a bit or if you want to watch again. That's all going to be online very shortly. I've also shared the link to the repo on GitHub in the chat. So I'll share that again just in case you missed it and so you don't have to keep scrolling. And that's their question. If anyone's typing, you've got a couple more seconds to let us know if you have a question. And there is one more question about if the participants if you will receive an email with all the recordings. We'll send that out today as well. Okay, I think we're all good on the question front. So maybe you could tell us a little bit of about the projects that you're working on and like use cases where you can use this technology.
Well, for example, we use, I'm not sure if I can talk about the customer we are working now for them, but for example, I can tell about my colleagues and I, we are using this system to as developing and production environments. For example, I started doing some tests, running different configurations in order to achieve the best setting for our customer, in order to keep all the resources at the minimum cost. And we started to do that in our personal training accounts and modifying all the projects that are allocated in the GitHub repos. Once we have more or less, or we are very close to our desired state for the project, we have just to change some pointers. So where do we want to to locate the new deployment to, for example, the customer infrastructure? And as we said before, just with one couple of clicks and creating a new URL, we're able to deploy or to reuse all the work already done. I think it is quite powerful for that. And also taking advantage of OpenShift and Satellite, we want to believe that we will able to use this asset or this future improved asset in different clouds too, not just our IBM cloud. I'm not sure anything else if I can tell you about more about this. Just saying that again, I'm not the owner or the only owner of this asset, of this tool. It is mainly code with a colleague, Guillermo Lopez, who is now on paternity leave, so he couldn't make it to stay here with us. And it is also a refactoring of previous project developed by the original IBM Garage here in Spain too, in Madrid. And we have just refactor it in order to understand it well, to try to improve, to try to simplify it a bit. And we're so happy with the results. And I mean, it's an open project, it's a live project, and everybody can try to improve it, or everybody could use it even for their own business. So we're happy to share this in order to facilitate the infrastructure deployment to everybody.
Wonderful. Yeah, I wanted to say a big congratulations.
Thank you.
Congratulations to Guillermo. Yeah, we're sorry he couldn't join us today, but he's got a very good excuse. And yeah, we hope to welcome him another time. That's really great. Thank you so much for more background information, and that's really putting it into context for our viewers today as well. So that's great stuff. And I love that you have these different windows and tabs, and seeing how it all fits in together. I mean, I know I often have too many tabs open, but it was so good seeing then all the ways how it relates to the architecture. I really liked the format.
Yeah, maybe it's if you don't have a great screen, or I couldn't see if you are watching that in a cell phone or a tablet, but I think the important is getting the idea. Is not reading the code, or because you have completely access to the code. We have it published in the GitHub, in the open GitHub, and but I think the important thing here was checking all the processes, following all the stages, how it was evolving, and also always without losing the look of the schema, no, in order to know more or less where we are. And
Yeah.
I think it is a nice way to show it.
Yeah, maybe just could you show the architecture a little bigger? That would be
Sure.
great to see that. I know Crowdcast does take a couple of seconds to buffer and to show us, but getting a bigger view of that would be
Sure.
great.
This is our internal repo, but you have already provided the public URL. It is
Yes.
just the same. Of course, just the master branch. We are developing several branches, so it is just the master branch. And as I said before, we have the Bluemix, the schematics, and the Terraform form. The image is one from the GitHub, and the README. I think it's quite self-explanatory. And here, this where we have the schema, the URL, trigger the tool creation. We have to click a couple of points here, and after that, all the process is completely automatic. It starts in a default resource group. It's the default container for IBM Cloud, but after that, it creates a customer resource group in which all the solutions are deployed. Again, the folders, we have the toolchain YAML, the pipeline YAML, and the deploy. It should be the same for all the projects. Maybe a very rare project should you should modify these files, and after that you have just drag and drop the IBM Cloud Service objects from an external folder, which are not one of them, and just play with the variable TF and the initial JSON TF.
Mm-hmm.
We have here more explanation, more in depth of what we have here, the toolchain creation, even all the commands in order to define this URL. For example, You have here the IBM Cloud CLI command to show all the locations, and I think it is quite explanatory. Then there is like a more in-depth, more advanced tool. This is the bonus track, and it is how to inject variables from URL params to Terraform templates. But it is a bit more advanced, and but I think it is everything very nicely documented here.
Super, that's great, thank you. Yeah, one of the questions we did get asked is, are there any hands-on tutorials for this? So I've posted a link to the repo, and it's great to see an in-depth look, have a good look at what that entails. So thanks, that's great.
Thank you.
Wonderful. So we're at the top of the hour. That flew by. We're now going to be moving on to our next session. But before we do, thank you so much again for joining us, Pedro, and thank you for your talk, for your hands-on, for your demo. It was great stuff, and I hope to see you again soon here, that we can have you back as a speaker again. Yeah.
Okay, thank you so much, Miriam. A real pleasure to stay here. Thank you. Bye.
Thanks. Bye. So, for those of you who are joining us now, if you're new to Crowdcast, we do have a chat here on the right, and lovely comments to Pedro there. And under the chat, yeah, you've got the chat text field, and then on the left of that you can see the polls we've got open, and also the ask a question section where you can ask our speakers your questions. At the bottom of your screen you've got the green button to sign in or sign up for the Code Labs, and you can also click the green button at the top right of your screen to follow our channel, so you're the first to hear all about our upcoming events. And if you're interested in infrastructure, we have a talk on Wednesday at 4 p.m. Central European summertime, and that's on CI/CD with Kubernetes. So I've posted the link. Make sure you sign up to that. And I'm going to get our next speakers onto the stage. Today we have the next talk as Modernize Your Machine Learning Workflow with Low-Code Tools. So I'm going to invite our speakers to the stage. They'll be joining us shortly. And we'll get going with the next session. Hello and welcome to the Developer Festival.
Hi.
Hi, Anam. Hi. Great to see you.
Thank you.
And I see Mridul is joining too.
Yeah. Hi, everyone.
Hi. Great to see you both. And we're 2 minutes past. The stage is yours. Welcome, welcome. And yeah, I'll hand it over to you.
Sure. Thank you so much. I'll just start by sharing my screen. Yeah, I hope you all can see my screen.
Looks good.
Yeah.
Looks great.
All right. Hi, everyone. Good morning, good evening, good afternoon. Thank you for joining us today. So today's session, we're going to be talking about how to modernize your machine learning workflow with low-code tools. With me, I have Anam Mahmood, who is an IBM developer advocate based in Dubai, and my name is Mridul Bhandari, and I'm also an IBM developer advocate based in Dubai. So for our agenda today, we're going to be first covering what is the use case, and we're going to be understanding the story behind the use case, and we're going to be trying to figure out what is the problem currently we are facing in this case study. And then we're going to be talking about what is Auto AI and the features and benefits of using Auto AI. And then we're going to be covering what are cloud functions. And then we would be moving on to what is the workshop use case for today and the proposed solution, which would be conducted by Anam. And then we'll have some useful links which we'll share with you regarding the session. So this is the survey link. You can go ahead and scan this and you can share your feedback with us on how we have done if you're not able to continue till the end of the session. So you can use your mobile phone cameras and scan the QR code, or you can just go on the survey link, which is displayed on the screen. That is ibm.biz/devfest2021-survey. And before we get started, I would like you all to sign up for the IBM Cloud account using this link, that is ibm.biz/devfest2021. If you've already created an IBM Cloud account, you can just sign in using this link. And you can follow along for the hands-on session on this link, that is ibm.biz/devfest2021-hands-on. The same link is also for the next session, which will be conducted by Fawaz and Khalil. So both the sessions are a joint workshop, and the slides also for both the sessions will be available on this link, that is devfest2021-slides. So to understand about the session, this session is divided in two parts. In the first part, we will be covering how to build a predictive machine learning model. You'll be downloading a data set and using Watson Studio to create a machine learning model to predict loan risk from an applicant. And we'll be utilizing AutoAI, a tool that automates your machine learning pipeline. And the next session, which is deploying a chatbot that is integrated to the machine learning model, that will be created in this session. This part will be conducted by Khalil and Fawaz. And they will be showing you how to connect your Watson Assistant with the help of REST APIs and connect functions, cloud functions to the machine learning model we'll be creating now. So the same architecture which we discussed today, this can be applied in different industries such as healthcare, retail, telecom, government, travel and transport, and oil and gas industries. So it could just be the use case might vary a bit, but the same architecture can be deployed in multiple use cases. And the use case we're covering today is related to the banking sector. So to understand the use case, we need to understand the actors in our story. So that we have three actors in the story. Firstly, we have the customer or the loan applicant who applies for the loan, and he or she is usually a customer of the bank, and the bank can also cater to customers coming in from different banks. Next, we have the financial institution or the bank, the entity that provides the loan to the loan applicant. And it is a key driver for the financial services sector. And the approval and denial of the loan solely depends on the criteria which the bank has evaluated the loan applicant on. And lastly, we have the credit bureau, which is the data collection agency. So they gather all the information from various creditors about the customer, and they provide the information they gather from all these various creditors to the bank, depending on which the bank approves and denies the loan for the loan applicant. So how it works today? So firstly, we have the loan applicant who applies to the bank for a certain amount, for a loan for a certain amount, and the bank contacts the credit bureau to retrieve the transaction records of the applicant. And once the credit bureau responds back to the request with the data, the transaction data, and the credit score, the bank then, based on the credit score and the eligibility requirements, approves or rejects the loan application. So this is how it works. There's a lot of to and fro. So firstly, the customer has to go to the bank, then it goes to the credit bureau, then the credit bureau gets back to the bank, and the bank responds back to the loan applicant depending on the approval and the rejection, what is the status of his loan. So this takes a lot of time, and it can take weeks or sometimes months depending on the amount. So in this session, we're going to be discussing how to innovate this process with the help of AI. So firstly, we'll be covering what is AutoAI. See, AutoAI helps you build and train high quality predictive models quickly, so you can simplify your AI lifecycle management. And this is based on AutoML. So what is AutoML? So AutoML is an automated machine learning platform which helps you in processing of automating the manual tasks that data scientists must complete as they build and train machine learning models. And these tasks can include feature engineering, hyperparameter optimization, selecting the model, or preparation of data, and you can also help with save and deploying a model. So this helps you to run and generate scores of multiple models simultaneously, and it helps you give the findings from these models. So it frees the data scientists from the role tasks involved in building a machine learning model pipeline, allowing them to focus on extracting the insights that are needed to solve important business problems. And the benefits and features of using Auto AI are, it helps you build your models faster. So you can save time that you usually spend in prepping your data and building your models. And it helps if you do not have any coding experience, that does not make a difference because it's very easy to build your pipelines using Auto AI. So you do not require any prior coding experience. You can go ahead and get started with the help of a few clicks, and you can build your entire pipeline. And you can, as you go ahead and keep utilizing this platform, you realize that you can use it for multiple use cases. So you can, build machine learning pipelines for various industries, which I mentioned earlier, like oil and gas, government, travel, and trade. So you can use it for various industries, and you can find useful insights to improve your business results. And with the help of the auto feature engineering process, it makes it very easy to extract the uh, predictive power from your data. So it helps you really identify the insights and select the features which actually play a role in your business and which do not. You can focus on those, and you can remove the other features from your data, and you particularly focus on those features that play a role in your business and that make a difference towards the results that are generated. You can also rank and explore models. So as I mentioned, you can quickly deploy multiple models. You can run, and you can see the results from these various models. So you can see the rank, and you can explore various models, and you do not need require you don't require any codings. So you can just go ahead and select the models you want to run. You can see, and then once you're done, you can set and deploy them using the REST APIs with just a few clicks. Next, we have IBM Cloud Functions, which is the next platform we're going to be utilizing today. So it is a fast programming platform, which is function as a service, and this is based on Apache OpenWhisk. So it helps you run your application code without servers and scale it automatically, and you pay nothing when it's not in use. So it helps you accelerate your deployment. You can reuse your code. You can simplify your migration, and it supports multiple languages such as Node.js, Python, Ruby, PHP, Swift, and many more. And the advantage of using this, you're only charged when you're using it, and it's not you're not billed when you're not using it. So it's really useful, and you can explicitly manage your namespaces, your dashboards using this. So you can save costs, scale, and integrate it into various applications with the help of a few clicks. So the workshop use case, which you're going to be using these two platforms to build, is going to be on banking sector, as I mentioned earlier. So we're going to be enhancing and automating the banking experience for loan applicants and banks regarding the applications. And we're going to try to automate the process for the banks to approve or reject the loan request. And the technologies we're going to be using is Auto AI in Watson Studio and Cloud Functions. And the session will be conducted by Anam. So, and this is the proposed architecture for our session today. This architecture combines both the sessions, the one after this, and we're going to be integrating the machine model which Anam is going to show us how to build with WhatsApp using Twilio, which will be conducted by Fawaz and Khalil. So, Anam, over to you.
Thank you, Mel, for the amazing presentation. Hope everybody is ready with their cloud accounts. Just post a yes in the chat if you're ready. If you have logged into IBM Cloud account and you're ready with this, with your services, with the dashboard of IBM Cloud account. I will share my screen now. Okay, I do see a few answers yes in the chat. Just a minute, I'm sharing my screen. And okay, so this is the hands-on link that we have already posted in the chat. If you check out the hands-on link, it's a GitHub repository that we have created for this session. It's a very comprehensive GitHub repository that contains all of the resources that you are going to need today. So we have the data set under the dataset folder. We have the slides for the workshop, and then we have the JSON skill set for assistant, which is for the part 2 of the workshop. And then comes the README. Now, in the README, you will find the description of the workshop. You'll find all the links that are associated, table of contents, prerequisites, and how to log into IBM Cloud account. I hope everybody is ready with their accounts, and we can just get started. This is the architecture diagram that Mritul just discussed. And now the next thing for us to do is to get on with the hands-on session. You can also answer the poll questions that we have in the poll section and let us know what you think. Now, when you click on the link that or on the green button that says sign in for the Code Labs, you will be redirected to this page over here where you will enter the email, password, and verify your email and personal information. And that's all you have to do. And the next thing you do is just click on login, and you can log into IBM Cloud account. Now, let me just log in really quick and we can get started then. So, okay, so if you have any questions, if you want me to slow down on any point, if you want me to repeat something, you can always put that in the chat. Or you can just go back to the repository and find out the steps that we are at and continue reading from there. It has all of the videos and step-by-step instructions to how to work along with us on this hands-on session. So now once you log into IBM Cloud account, this is the page that you're going to land up onto. Just a minute, and this is the dashboard we will have. If you have already followed along with the previous hands-on sessions, you will have a few services that are already created. In case any of the services are overlapping, you can continue to use the service that you created earlier, and you can use those services to continue with our workshop. Now, the first thing that we will be creating today is Watson Studio. So Watson Studio is basically a one-stop shop for all your data science needs. It gives you all the requirements that you need for your data science needs. You can create your, so you can create, one second. So you can create your machine learning models in there. You can create your notebooks, and you can run your auto experiments, anything that you prefer, you can do it. All your data, basically end-to-end journey for your data science needs. Now, if you click on Watson Studio, you will land up onto this page over here. And over here, so you can select a location. I'm choosing Dallas, US South. Make sure you select the light plan, which is the free plan for this service. And you can select that plan. Next, we will move on to give your Watson service a name, and you can click on I have read and agree to the following license agreements and click on create. Okay, so what you're going to do is search for Watson Studio in the search bar. Select a region. This is very important. Just remember the region that you select is exactly the region that we will be building our machine learning instance through. So you have to keep the instance same. And give your service a name. Check the button and check the checkbox that says I have read and agreed to the following license terms and agreements, and then you can click on create. Now I'm not clicking on create because I already have a service, so I'm just going to go ahead and find that. Okay, so once I click on the service that I have already created, it will redirect me to a page over here. And on this page, you can manage your resources. You can change the plan if needed. You can find a few, and then over here, you can find documentation and some gallery for projects and notebooks. Now, once you click on Get Started, it's going to redirect you to another tab. Yeah, I have a question from Bober. It's are we creating a service on the cloud now? Yes, we are. So the first service we are creating is Watson Studio. Search for Watson Studio in the tab. If you search for Watson Studio over here, it's going to redirect you to the page where you will create your service instance. So right here in the catalog results. And once again, if you have already created Watson Studio service instance in one of the previous code sessions, please don't create it again. You can continue to use that the one that you just created. So you can use that. You don't have to create another one, because on the light plan, you are only eligible for one free service instance for each app, for each service, right? So if you already have a free Watson Studio service, please use that. So Watson Studio, search for Watson Studio, and then select a location. I'm using Dallas, US South. Make sure you are on the light plan, and then go ahead and give your service a name and check out this box over here and click on create. Once you click on create, you'll be redirected to another page. On that page, click on the blue button that says get started. Once you click on get started, you will be taken to a page over here. Now, in case if it says Watson Studio or IBM Cloud Pack for Data, you don't need to worry. It's the same. Watson Studio is just going under a rebranding. So don't worry about it. We're all on the same platform as of now. Okay, if all of you are on this page, please put a yes in the chat so I can proceed. And just don't worry, the session is being recorded and will be available afterwards. And you can watch the recording later on and then follow along as well. Rochana, what page are you on? You can put it on in the chat and I can guide you through that. So once you do it over here, you can create it. The next page is going to take you to the Watson Studio main page, and over there you can click on get started. Once you click on get started, it will take you to this new page over here. Yes, so that's a double authentication system that is installed. You just put in your information, is just for verification purposes. Just put your information that it's asking for, and you can proceed with it. That does happen sometimes when you keep your IBM page open for too long and it needs to verify you again. It's just purely for verification purposes. Okay, I do see a few yeses. So we're going to go ahead and create a project. Now under work with data, you will find a button that says, a link that says create a project. So let's go ahead and click on create a project. All right, so over here, you can either select create an empty project or create a project from a sample file. For this demo, we're going to be using create an empty project. So click on create an empty project. You can select Watson Studio. You can select machine learning service. Another question from Roshana is, I'm being asked for which service to provision. In case you are facing the same issue, you can also put in Watson. You can also enter Watson Studio, machine learning, cloud storage, and click and just go ahead with that. So I'll give a minute so everybody's on the same page. If you are on the new project page, just put a yes in the chat as well. So we're creating an empty project for this service. We're not using a sample file. That's fine. Watson Studio works. With Watson Studio, you can get access to machine learning and object storage as well. So that's fine. And then once under work with data, you can click on create a project. On the next page, you will select create an empty project, and this is the page that we're going to end up on. If you're on this page, please put a yes, so everybody is on the same page and we can continue. Great, I see yeses. So now we're going to give our project a name, and then we're going to create a cloud object storage instance. So let's give our project a name. You can give it anything. Now, because this is a bank, yes, just give me a minute. I'll show you how to add it. So if you do bank, I'm just doing. Okay, now over here, if you select, so for you, if this is the first time you are, this is the first time you are still creating a project for a cloud storage object, it will say add storage. Let me just show you in the GitHub repository. So here, this is what you will see. You will see the add storage service. When you click on add, you will select one free account, give your service instance a name, and then click on create. It will take you back to the page we were on, and then you can click on refresh. Okay, so you can see we have all the steps over here. On the new project page, give your project a name. You will need to associate an IBM Cloud Object Storage instance to store the data set that we're uploading. And then under select storage service, click on the add button. This takes you to the IBM Cloud Object Storage Service page. On that, make sure you select the light plan and click on create. It will bring you back to the new project page, and then just click on refresh and click on create. So I already have a service created. I'm using that same service. If you already have a service created from earlier workshops, use that. Once again, I will bring you back. No, you are working on IBM Cloud. We have a question from Bober which says where's the project is being stored and what if it will fill up my computer memory? It's not going to. We're working with the cloud, and that's the beauty of it. It doesn't take up space on your machine itself. This is a storage object that is being created in the cloud and will save the data in the cloud. So nothing from your machine's memory is being used. So since another thing we can do for now is you can all download this GitHub repository. You can just click on code and download the zip file, because we will be using the dataset and the JSON file for the Watson Assistant and dataset for our Auto AI project. And once you download it, you will have access to both of these files that you can use easily. So once all of you are on this part and you have created your cloud object storage, click on create. If you click on create, just put a yes so I can proceed with the creation as well. Because to repeat the steps, it's going to be really hard coming back on this page. Just once you click on create, let me know. Okay, so okay, we have a yes, just waiting for a few more people. Great, so we can proceed. Okay, I will click on create. Yes, I will post the GitHub repository for you in the chat. There you go. So now this is the page that we are on. I will give everybody a minute to download the GitHub repository, because the next thing we're going to do is we're going to upload our data set. Again, once again, for anybody who is confused, we are using IBM Cloud account. The services we are creating are not being saved on our machine. No memory from our machine is being used up. We are purely using IBM Cloud account, and we are saving all of our data, our projects, and everything onto the cloud. So we are not using anything from our machine memory. Okay, now everybody just take a minute, download the repository and put a yes in the chat. In the meantime, I will walk you through the Watson this platform and this page over here, so you have an idea if you're working afterwards of what all these tabs are about. Okay, so I see a yes, and let's just explain what the page is this. So this is the overview page of the project that we just created. It's an empty project, so there's nothing. We have 0 bytes used from the cloud object storage, and then there's one person who is a collaborator in this project. You can add collaborators, which is if you're working with a team, you can add different people. If you move on to, I'll come back to the assets tab in the end. So if you move on to the environments page, now in the environments page, this is for running your notebooks. If you have Python, Spark, or R notebooks, you can run all of these. We have different environments that are already defined for us. If you need to add a new environment specific modification, you can create a new environment right here. Okay, and so if you have any active runtimes, that will show up here. Now in the jobs, there might be some jobs that you want to run after 6 months or twice a week or something. You can create those jobs here. Sorry, and that will run on the scheduled time that you have. So you don't have to worry about like remembering the time where you have to run it. It will be automated for you. Now, in the access control, you can add different collaborators and different services from IBM Cloud account, and you can associate them right here. Now, in the collaborators, once you add them, you can give them different levels of permission. So the permissions is basically, I created the project. This is my project. I am the admin of the project. I have full access to the project. I can even delete this project. Now, if you want someone else to have the same privileges, you can give them the admin right. If you want them to only edit the project and not be able to delete it, not give them full access to your project, you can give them the editor view. And if you want someone to just have a look at your project and do nothing, no changes at all, you can give them the the viewer permission. Okay, so these are different different permissions that you can associate to different people. In the settings page, you will find the project name that you have, then the storage, how you can manage it from here, how much storage you have used. You can associate different services from here. So if you click on this add service button here, you can associate analytics, dashboards, Watson Assistant, Watson machine learning, and all of these services can be associated from here. You can do data replication. You can integrate your notebooks or any of your projects directly to GitHub repositories. And every time there's a change, you can easily see what's happening. Now, coming back to the assets tab over here. Now, assets is where all your assets are being saved, okay? Your data sets are being saved, the notebooks that you create are being saved, your experiments that you run are being saved, any refinery flows that you have, that all of that will be saved here. So now the GitHub repository that you downloaded, you can click over, you can browse that repository, okay? And in the dataset folder, you will find, just go to the repository wherever you saved it. And under dataset, you will find the dataset that we have to upload for today's workshop. So click on that the dataset and click on open. You can also drag and drop the file onto the page and it will do the same thing. Now over here on the right, you can see it's uploading the dataset and creating the dataset. It's creating a data asset now. Once it's done, you'll find it over here. So right here, you have the data set. If you have uploaded the data set, again, please post a yes in the chat so I know we're on the same page. Now, if I just click on the data set to show you what the data looks like, okay, great. Everybody's following along. So we have these fields over here. We have 15 columns, and these are the first 1,000 rows that are being shown over here. You have loan duration, loan purpose, loan amount, existing savings, employment duration, installment. So what, like Mridul mentioned, we are trying to do is we're going to predict if the person has a risk, if the application they're submitting for loan is a risk application or a non-risk application. So we are taking their information that we have, and through that, we're going to make predictions out of this data set, right? Or any other things that we enter. It will give us it will give us if they are risk or no risk. So now this is what we're trying to do. If you have a data set that needs to be cleaned or something, you can actually do the refining over here as well. But for us, this data has already been refined and uploaded for your for this purpose. Now, if I go back to the workshop, the project, now what we're going to do is we're going to create our Auto AI project. It's a no-code application, so or for this part, it requires no coding, right? So we're just going to click on Add to Project button over here. On the top right, you will find. So we have a question from Bober that says, are we creating an app on behalf of a bank that serves for a bank? So basically that is the idea, but this is just a demo. It's not a completed application, not an end-to-end application. There is a lot of things, security and everything that has to come into play. But what we're doing is we're trying to reduce the time that it takes to process a loan application. It can take from weeks to months for an application to process because there's just so much documentation, and people are just anticipating what's wrong with their application or anything. So what we're doing is we're creating a machine learning model to which, and then we're going to create in the second part of the workshop, which is conducted by Fawaz and Khalil, we are going to connect this workshop with the Watson Assistant through Cloud Functions, right? And in that Watson Assistant, it will ask you a few questions. You will enter the amounts, you will enter the answers to those questions, and it will give you a prediction of what it thinks. Now, this is just for demonstration purposes, and it can be refined to a longer extent as well, right? So where you are connecting the data to the users to the database of the banks and everything. And then you have securities and all of those things come into play. But we are just doing a simple demonstration, and this process can actually be taken to retail, marketing, and all of these different sectors as well. So we're just doing a loan risk prediction application right now. Now, if you click on Add to Project button over here, you will find different asset types that you can create. You can create data, you can connect your data, you can create connections from your data, auto experiment, notebooks, dashboard, deep learning experiments, data refinery flows, visual recognition. So what we're doing today is we're creating auto AI experiments. So just go ahead and click on auto AI experiment. So what we're doing is we're clicking on the Add to Project button. In the Add to Project button, we're selecting Auto AI Experiment. Okay. So let's give our service, so let's give our experiment a name. And over here, you will find a link that says associate a machine learning instance. First of all, if you're on the same page, please put a yes so that I will proceed with the machine learning instance. Okay. Let's give it another 30 seconds for everyone to be on the same page. Great. So now we're going to associate our machine learning service instance to this. And that machine learning instance is what's going to give us what's going to help us create the whole pipeline and then give us predictions. Yes, we have a question that says, can we create a service on the IBM Cloud that runs 24/7 without interruption? Yes, you can. So associate a machine learning service instance right here. Click on that and it will take you to a next page. Now on this next page, we're going to create a machine learning instance. If you have created a machine learning instance in one of the previous sessions, please use that. It's totally fine. If you have not, I'll show you how to create a new one. You can click on new service. In the new service, once you click on new service, this pop-up page over here, you can scroll down to machine learning. So these are all the different services that you can connect with your AutoAI experiment. But what we need today is the machine learning. So just click on machine learning. Okay, once you click on machine learning, it will redirect you to this page. Now, this is very important. Make sure the region that you select here is the same region where your Watson Studio service is was created. Okay, so you need to make sure where it was created. This is why I said earlier, please remember where you created. Mine was in the Dallas region. So this is what I will be using, Dallas. Okay, in case you don't remember, you can just go back to Watson Studio homepage, click on the hamburger sign, go to resource list, and over here in one of the columns, you will find the region for your services. So you can see location, and then under in your location section, you will find it. Okay, so these are over here. Now coming back to this page, select the region, the same as your Watson Studio service. Mine is Dallas, so that's what I'm choosing. Select the light plan, scroll down, give your service a name, and create it. I already have one created and I'm using the same one, so I'm not creating another one. Okay, so new service. In the pop-up page, scroll down to machine learning. On the next page, select the same region that your Watson Studio service is created. Mine was Dallas, so leave it as Dallas. Scroll, make sure you're on the light plan. That's a free plan, and one service per account is allowed. Next, scroll down, give your service a name, and click on create. I'm just going to go down, select my service. Okay, so this is my service here. Now you can see just there's a question that says I cannot link service to AutoAI. Can you please tell us what error you're getting? Or even try refreshing, it will work. So this is my service. You can see over here it says not associated. Now if I scroll back to the top of the page, it says one item selected, associate service. Great. So once you click on associate service, how do you go back? Or back to where? Great, awesome. So we have services working. Please, Rachana, please can you tell us, go back to which page you're talking about? Now, let me just give us. Okay, so once you click on the new service button in the pop-up page, you will find machine learning. Oh, great. So it's working. So for anyone who's stuck, click on new service in the pop-up page, select machine learning. It will take you to a new page, select the region, the same as the Watson Studio region that you created, and then scroll down, select the light plan, scroll further down, give your service a name, and click on create. It will take you back to this page over here. Now, if I search for mine over here, so over here you can see machine learning associated. Now this is associated, okay? And just close this tab and you can go back to this tab over here. If you reload it's going to associate the service over here. Now your service instance should show up right here. If you're done, please put yes in the chat and then we'll proceed. If you click on create, just put a yes in the chat and we will proceed with the next part. Okay. Okay, so now we can click on, let me just click on create. All right, so now in add data sources, we have already uploaded our data set. In case you did not upload it, you can upload it over here through browse and just drop the files. It will detect it and upload it for you, but we have already uploaded the project. So select from project. So click on select from project. Click on data asset. You'll find the service, the data set that we uploaded right here. Click on that and select. And then click on the blue button that says select asset. Are we on the same page now? One more yes, and the next thing we are doing is we are going to run our experiment, but before that, I will show you a few settings and then we will proceed to running the experiment. Okay, so we're not doing time forecast. If anybody is interested, we do have time forecast series. Now, what do you want to predict? This is very important, okay? So what we want to predict is the risk field in the data set. We have 15 fields, but what we need to predict is if the person submitting the application is at a risk or not, right? So for that, scroll down and you will find the field in the end that says risk. So select risk. Okay, please make sure that what you want to predict is the field risk, because that is what we are predicting. We need to see if there is a risk to the application or not, right? Now you saw in just a second, it gave us the prediction type. It's a binary classification type. We are trying to predict no risk, and it's running for optimized and it's optimized for accuracy and runtime. We have a question that says, aren't we going to separate the data into training and target sections? Yes, and Auto AI will automatically do that. I will show you. Just give me a minute. Now, in the experiment settings, if you click on experiment settings, you can see if you want to change the type to multi-classification, you can do that. And over here, we are doing risk, and its accuracy is the recommended one. We're choosing accuracy, and algorithms included. Over here, you will find the different algorithms that are being included for the experiment purpose. It will read the data, and then it will choose the best algorithm out of these. And the number of pipelines that are being generated for this is 2. You can increase it to 3, 4, or even just 1, but we're just using 2. Now, if you go to the data source tab, if there are any duplicate rows, it's going to skip those duplicate rows and then use text feature engineering. We have that enabled as well. And here, so you can see final training data set. You can either choose training data only, or you can choose training data and holdout. Now, what this does is it splits the data, right? So training split, so you can change the amount it is splitting and or how much to hold back and not. So right now, what it split it has done is we have training data. It's split into 90%, and 10% is kept as a holdout. Okay, so that answers your question. I hope so. We have different fields over here that you can remove if you want to. For example, if you think that there's going to be some sort of a bias because of a field, you can either refine it out or you can exclude it from here itself. That's really up to you. And in the runtime, we just have a few information about the project, right? So I'm not changing any data, any settings from here, just showing you how it works. For this purpose, I'm not changing any settings. Now we have all the settings ready, so we can go ahead and run the experiment. So click on run experiment. This usually takes up to 60 to 90 seconds to actually complete the whole process and create all the 8 pipelines. But everybody has a different Wi-Fi connection, and that can change, right? Okay, so now it's starting the Auto AI experiment. Okay, now it's downloading the source data. 1 second. I will so you can switch the view over here. Mm, 1 second. My internet is acting up. Okay. So over here, my internet is acting up. Just give me a minute. For everybody else, this should have started reading the data and continue down the pipeline. Oh, there. So what it did is it started reading the data set, then took out the split, it did the split for the holdout data. Now, then it started reading the training data. The next thing it did is it's doing the pre-processing and model selection. So in the model selection, if you remember, we had a few algorithms to choose from. So it after reading the data, it sees which is the best algorithm to go with. And then it starts creating pipelines for those. So the first pipeline that it has, the first algorithm it chose is XGB classifier. It created a pipeline. Next, it did a hyperparameter optimization and created a pipeline. Next, it did feature engineering, created a pipeline, and then again hyperparameter optimization. Same for the part 2. It selected snap random forest classifier. Then create a pipeline, hyperparameter pipeline, feature engineering pipeline, hyperparameter, and then again another pipeline, right? So now once you see this, so it's going to keep doing that till we have 8 different pipelines. Now if you see, we are almost finishing it up. It's almost done. And in the pipeline leaderboard, you will find all of the pipelines that it created. We had the optimization metric as accuracy. So according to accuracy, pipeline 8 happens to be the best pipeline for our build time. Now, we have a question that says, what are, oh, there was another question. So there's another question that says, can these kind of projects handle continuous data? Fawaz has answered that question. Training in Target is done by Auto AI itself. You can make it continuous with the help of data replication. If you're talking about continuous data type, it can manage that too. Now we have another question that says, what are these pipelines? So when you run an algorithm, whether it's using notebooks or any Auto AI experiment or any other softwares that you might have used, you create pipelines for your machine learning models. right? In those pipelines, you set an optimized metric. For us, it's accuracy over here. And then once you run your algorithm, you will see which is the best metric, right? Which is the highest metric that's giving you. For us, for example, it's accuracy. So now all of the over here, we're going to see which pipeline that was created through our data set and algorithms has the highest accuracy. So this is the pipeline 8 is where the highest accuracy comes in, and that came through the process of using Snap Forest classifier, one hyperparameter optimization, then another feature engineering, and then another hyperparameter optimization, right? So this was the pipeline that completed and gave us the best one for us to use with the highest accuracy. So if you click on this pipeline right here, this is the best one, and you can see it has a star and it's on the top. You can click on this one here. So we're going to click as Save As and select Model and click on Create. Now click on View in Project. And click on Promote to Deployment Space. Okay, now we're just going to deploy our model so that we can use it with Cloud Functions. Okay, so we're going to create a space. You can click on Create a New Deployment Space. So deployment name. Just giving it a name over here. Scroll down, and over here, make sure you select the storage service that we created. Okay, there. So, and this is very important. Make sure you also select your machine learning instance. Jana, do you mean you didn't understand what a pipeline is, or have your process not been completed? So machine learning demo over here. So this is the machine learning service instance that we created. This is very important. Otherwise, your deployment will not work. Okay, just give me a minute and I will explain it. Or Fawaz, can you put it in the chat what pipeline is? We're kind of running out of time, and I really want to show the Cloud Functions part of it. So let's close this and go to the model. Just check the box that says go to the model in the space after promoting and click on Promote. Okay, now just click on New Deployment over here. Click on Online. You can give it a name. and click on create. I'm sorry, but you can also watch the recording and I really want to finish the hands-on session. We're kind of running out of time, but I want to show you the Cloud Function set. You can also find the steps in the GitHub repository, and you can view it from there. All right, so we're almost done with the AutoAI experiment, right? So if we go back to the IBM Cloud account, just one sec, I'll show you the last bit of it. So over here, we are done. If you click on the bank loan over here, it will take you to a new page. And this is the API endpoint that we will be using. So just keep this page here. And if you say go to test, you can actually test. Yes, we did create online deployment. Okay, you can test with different, you can choose a row from the data set, enter the information, and then see if your experiment worked properly. But I'm not doing that. I'm just going to go back to IBM Cloud account main over here, go to and search. So everybody just go to the main page, search for functions. And select functions. In the catalog results, select functions. Now, once you come to functions, you might not have a namespace. You can create a namespace, okay, like over here. So you have a namespace, or you can just click on the drop down and click on create a namespace. Give it a name. Choose the default. Choose the region. I'm just using Dallas to be constant, and I'll just close this. And in the actions, so click on actions. Okay, once you click on actions, click on create. Click on create and click on action again. Okay, now give your action a name. I'm just giving it dev workshop. In the package, we're just keeping it default, and runtime, please use Python 3.7 because the code we have is Python 3.7. And we have a question that says, now we're creating an application for the pipelines. So we're creating actually, and click on create over here. So we created the pipelines. Now we're creating, we have a code snippet that we're going to use and put it over here, which will actually run as an application for us, okay? So we don't need to actually go through creating a whole application. We can just use a code snippet to do the same for us. If you go to the GitHub repository, scroll down, if you keep scrolling, okay, so here, this is all the steps that we have. Okay, so this is the repository, this is the code that we have. Just copy this code and go back to Cloud Functions over here, paste that here. Okay, and you can see over here we have like things like this. Now this is where Watson Assistant will come in and join us. One last thing that we have to do is we have to create an access key. It's very simple. Go to IBM Cloud account under manage. So under manage, you can see access IAM. Click on access IAM. Ruchana, I'm really sorry. I can actually continue repeating the steps after the session in the chat, but we are out of time right now, and I need to hand it over to Fawaz and Khalil to continue with the next steps. You can always refer back to the GitHub repository. But after the session is completed, I will put down all the steps in the chat for you. So click on Create IBM Cloud API Key. And let's just give it Dev Workshop again and click on Create. Now, please download this key and keep it with you, save, because after you close this, you will not be able to view your API key. So please download it and keep it with you. So just copy this. And if you go back to Cloud Functions in the parameters, you can click on Add Parameters and click on API_key, because this is what we have used in the code. So you have to keep the name the same so you can understand where to get the API key. Now you need to put double quotation marks and paste the key inside it and save it. Okay, so once you save it, go to runtime. Sorry, go to endpoints, and we're going to enable as a web action. Okay, and we're going to click on save. Now we have this that will be used in the Watson Assistant. One last thing that we will do is we will copy this endpoint right here, the one that we created our pipeline, so it's something to connect everything together, right? So we will click on this endpoint over here, go back to Cloud Functions. The code is right here, right? So in the code, scroll down to response scoring. Okay, one second, scroll down. So you can see over here, it says add your machine learning deployment URL, paste that code right here and save it. Okay, so you can save it, and that's it for the session. So just to summarize very quick, and so we created an auto AI experiment, and we created pipelines. We saved the best pipeline. We then created Cloud Functions. With that, we created access key, pasted in the parameters key. And in the endpoint session, we enabled as a web action so that you can use it in the next session that we have. In the code, we bought the endpoints from our machine learning model and pasted that over here. You can see over here, it says API_key. That's how it's going to know that this parameter is for that API key. And with that, thank you, everyone. Hope you all liked our session. I know the end part of it was a bit rushed, but it's being recorded. You can always watch the recording, and we have the GitHub repository with very comprehensive, all the resources that you need. And so that's it. Thank you, everyone. Please don't forget to fill up the survey form. Sorry.
Thank you. That's so great. All the useful links are in one place. I see in the chat. It looks awesome. Lots of links and lots of resources. Thank you so much for your session. It was really wonderful having you as part of the Developer Festival. And I'm been following along in the chat. Everyone's loving this session and keeping up with what's going on. And the next session is building up on this first workshop, so it's a perfect segue into the next session. Thank you so much for your wonderful workshop.
Thank you.
Both of you, Anam and Rida.
Yeah, thank you. And if there's any questions, just keep posting in the chat, and I will keep answering them for our session as well as the next one.
Thanks, that's great. For those of you who are just joining, we're in the middle of our Developer Festival, and it's a full program of 3 days with 13 different sessions. If you're new to Crowdcast, the chat's on the right. There's polls at the bottom of your screen and the option to ask a question to our speakers. And there's a green button at the bottom of your screen where you can sign in or sign up to IBM Cloud for access to the code labs and all the workshops. And now we have the fourth session today. Quickly integrate a machine learning model in your chatbot and deploy to WhatsApp. I can't wait for this session. And we've got Khalil and Fawaz in today talking to us, taking us through this workshop. Welcome to the stage. And yeah, I'd love to hand it over to you both.
Thank you. Thank you so much, Miriam. And thank you so much to everyone for being here all this while. Finally reached the last session, and it's going to be amazing. So let's not wait. Let's get started. So let me just share my screen. All right. So I hope you all can see my screen. I'm just going to confirm. All right. You all can see my screen. All right. So now we'll be quickly integrating a machine learning model that you've created in the previous workshop with a chatbot and deployed to in WhatsApp. My name is Fawaz Siddiqui, and I'm a developer advocate at IBM. And with me, I have Khalil Faraj, who is also a developer advocate, and we both are located in the United Arab Emirates. So the agenda is we're going to revise the use case, the problem statement in the previous session. We're going to talk about chatbots, Watson Assistant, the features of Watson Assistant, the integrations, Twilio, WhatsApp, and then we're going to go ahead with the workshop, and Khalil will be doing the workshop, and then we're going to basically summarize the entire session with some useful links. So do let us know how we are doing. Go to the survey link or scan the barcode to let us know how you feel about the session, and we'll be able to we'll be able to analyze and what's better for you in the future events. And let's get started, right? So I hope everyone has an IBM account, IBM Cloud account now. If you don't, you can go ahead and sign up on this link. You need to sign up for Twilio. So it's twilio.com/try Twilio. The hands-on link is same, just like the previous workshop, because this is a continuation, and you can find both the slide sets in the slides link. So what happened is that there are three actors in our story. There's the customer, the bank, and the credit bureau, where the customer is applying for the loan. The bank is the entity that provides the loan to the customer, and credit bureau is basically the data collection agency who provides the bank information about the customer. And today it's very not digitalized, right? Where the customer has to go to the bank, then they have to go to the credit bureau, and then they need to credit bureau sends the data back to the bank and then back to the customer. It takes some time. And it takes at times it takes about a month. So how do we really change and make it AI infused, right? So what we've done right now is basically create the machine learning model to basically get the risk. And that way we'll be able to give a primary approval for the user that once if it is approved, the bank can start the loan providing process here. So we've integrated the first part, which is basically creating the machine learning model. Now we'll be integrating it into Watson Assistant, and we'll be able to link that Watson Assistant to WhatsApp. So the overall architecture will be very simple, where we have, let me just pull out a laser pointer. Okay, where we have the user, which is basically anyone who's in your ecosystem as a user, interacting with WhatsApp, which is interacting with Twilio, and then it's going to interact with Watson Assistant, the cloud function that you just created a while back, and the machine learning model as created on Watson Studio. So what are chatbots? So they're basically the AI or the artificial intelligence part of things, where it's basically mimicking human intelligence. It's talking in natural language, and it's allowing users to interact with a system in a natural way. So for example, if you're talking about something just like a normal chat with your friend, you're able to chat through chatbots, and artificial intelligence is basically mimicking that human conversation with the help of natural language and multiple things. And why do we really need chatbots? Well, first of all, it's the accessibility. They're accessible anywhere, on your website, on a mobile application, and anywhere else. Then there's a high amount of capacity for it to handle. You can handle multiple queries at once. You get platform agnostics with customer insights, and you also know how satisfied your customer is. Moreover, it's very cost effective, and also it can provide automation to your workflows. So this could be anything. Maybe the user wants to pay for their credit card, and they can just enter the credit card number, and they'll be done with the payment through that, and that's basically automated. So it unlocks a very wide and broad set of features for an organization or for anyone actually. So with IBM Watson Assistant, it's basically IBM's conversational AI platform that can engage your customers to get them what they want, when they want it, through any channel. So I will be explaining to what they about all of these three things in the upcoming slides. So the chatbot roadmap, this is the what they want part, where you need to know your audience. You need to know what your audience wants. You need to set your specific goal, where you need to define a task that is bound to be completed, and then you design conversations flow. So conversations flow are basically how your conversation is going to go through a customer or through a user of your chatbot. And you need to visualize those. So by visualize, it means, hey, do these conversations actually make sense? And you need to also provide empathy that, hey, a user will be interacting with a natural way, so I need to adjust it according to that. So these two are very iterative steps, and you need to go through these steps multiple times before coming to a perfect chatbot solution. You need to make it easier for your customers, not difficult. So with Watson Assistant, we have three things. First of all, we have intents, basically what the user intends to communicate, right? Then there's the entity, the words and objects that give more context to the user's questions. And then there's the dialogue, which is basically the flow of the conversations, and it includes the intents and the entities, and they're basically detected to complete a certain task. So how does it really work? Well, it's just a matter of if then else, right? It's not what the memes that we see online know. It's basically guiding the entire conversation through multiple statements, through multiple nodes, right? So first of all, it's the user input. You get the user input, and based on that user input, it goes to a particular node. So the user input may have a condition, right? I'm going to explain that condition in the next picture, which is on our right side. And based on those conditions, it checks for subconditions and gives you the response that is required. So for example, let's say, what are your cupcake flavors? It goes to the first node. It checks if it is asking from a cupcake menu. Then it asks the user, do you want regular cupcakes or gluten-free cupcakes? Well, if the user types gluten-free, then they get the gluten-free options. And if the user types the normal cupcakes, they get the cupcakes which are not gluten-free if they're not really picky about that. So this is how it actually works. As you see that the whole conversation is being driven around with the help of nodes and child nodes to give user responses to a particular query that they're having. So with Watson Assistant, like I mentioned, the channels part, and so this is what we're coming at. Now, Watson Assistant has an integrated web chat, so you just have to copy a set of code, and you can paste it on your website to get a web chat option on the fly, and you don't even have to, and it's customizable. So that's the amazing part, and it really saves time in terms of development and also speeding up your product delivery. Then there's disambiguation. So in case the assistant cannot understand what's happening, what the user is asking for, it provides for recommendations, as you can see. If the person just says, I'm traveling, okay, you're traveling. Are you looking for travel tips? Do you want to set up a travel alert, or none of the above? So it doesn't jump to conclusions. It asks for clarification so that the user gets what they want. Then there are slots, basically connecting and collecting more information from the user. So let's say if somebody asks the assistant that we're watching is to set up a travel alert, and the person just said, I'm traveling to Rome tomorrow, but the assistant needs more information, and with the help of slots we can get that. So the assistant is asking, when do you come back? In a week, and then it basically gives a final output towards the request of the user. So it collects more information to complete a particular task, and basically here, as you can see, the configuration of the slots is basically getting the location, we have the location as Rome. We have the departure date, which is depart date, which is tomorrow. And then return date was missing. Then the assistant asked, when are you returning back? In a week. So it was able to process these requests for the user. Then there's webhooks, something which we will be using today. Is basically, you've already defined a function. We're going to take that function, which is running a machine, which is connected to a machine learning model, and basically get the data from that machine learning model to our assistant. So it's basically getting information from different basically getting external data from different sources that you've connected. And then there's search skill, basically linking your existing knowledge base with the help of Watson Discovery. So you can basically extend the coverage of your existing content by uploading it on Watson Discovery and basically getting the answers built in. And there's pre-built connectors for you to just use. It's just a plug and play thing, and you'd be able to deploy a search skill right away. And then there's analytics. So it's not only about just the conversations. It's also about, hey, is the user getting what I want, what they want? And that's where the analytics comes in, where you get the total conversations and you get the average messages per conversations. The main idea is that you need to have the least messages to get the task done, because customers want things fast. So that is something and that's the main goal. So as easy as it can, you need to make it very simplified for the user. And also there's weak understanding. So if in case the user is typing something, you need to ensure that, hey, let's fix this up. It's an iterative step, right? So you can improve your chatbot as and when it's in production, and it's on the go and it's quick. And then there's intent recommendations. So you've already uploaded some intents. You start getting recommendations of different intents that you could use to further enhance your chatbot. And the most important thing, you can deploy it anywhere. So Cloud Pak for Data running on top of Red Hat OpenShift on different clouds, including private clouds, IBM Cloud, Azure, AWS, and hyperconverged cloud systems. You can basically run Cloud Pak for Data on top of Red Hat OpenShift. That way you can deploy your chatbot anywhere at any point. And it's even on premise as well. So that is the main beauty of this, that with this confidence, it's easier for us to deploy it anywhere, wherever we want it to deploy. So it's simple to build, simple to maintain, deploy in days, not months. And you can integrate it with anything. So now we're going to talk about the channels, the language, system, content, or human, right? So you can deploy it to multiple channels. You can connect your assistant to a phone line, or on a website, on a phone application, Slack, Messenger, and WhatsApp. And today our user base is going to be based on WhatsApp. Any language, we have a universal language model where you can deploy your chatbot with any language that you like, and any incoming content. So you could be getting content from the web, from PDFs, from databases, and that can be integrated. It's not just one data source that we're stuck to. There are multiple data sources, and any system. So it could be anything at all where you want the assistant to be a part of the ecosystem. It can adjust right there. And finally, you can integrate it with any customer service platforms. So you can connect through IVRs, such as Salesforce, Zendesk, Intercom, Genesys, Twilio, Cisco, NICE, Contact, and Avaya. So I just mentioned Twilio. So what is Twilio? That's something that I'll be using today. And basically, it's a developer platform for communication. So it provides a link between the internet and the telecom networks. So that's basically voice, SMS, and all of these things. And it helps to add capabilities like voice and video and messaging to applications. It's a very well-known platform for this, and they're one of the best in this sector. And when it comes to WhatsApp, it's a popular messaging service over 100 countries. So we all use WhatsApp. Let's be very honest, right? And and we all know how important part of our lives it is. So you have the availability of business profiles these days, and you get so the advantages of using WhatsApp. It's a familiar platform, easy to use. There's multi-action engagement, ease of access, conversation histories there. There's bot to human handover, and there's also chatbot analytics. And in numbers, we have around 1 billion daily active users on WhatsApp, with 3 million WhatsApp business users and 65 million WhatsApp messages sent per day. That's around 29 million per minute. And then there's some largest market WhatsApp markets such as India and Brazil, and they have the highest penetration rates in Netherlands, Spain, and Italy. So now you have developed the machine learning model in the previous workshop, where you are marking users if they're going to be a risk to give a loan or not. We've already developed that. Now we'll be linking that machine learning model to our instance, and that's what this workshop will be focusing on. So again, just wanted to revise the architecture. We have the user interacting with WhatsApp. Then there's Twilio connecting the internet to the telecom networks. Then there's Watson Assistant, Cloud Functions, Watson Studio, which is basically getting the data set to create the machine learning model. So with no further delays, Khalil, over to you.
All right. Thank you, Fawaz. Hey, everyone. I'm Khalil. Just give me a second to share my lovely screen. Okay. I hope you can see my screen. By the way, can you hear me well, Fawaz? Can you just let me know if you can hear me well, just to double check?
I can. Can you speak once more?
Yeah, I'm speaking right now. Is it okay?
Yeah, sounds
All
good.
right.
Over to you.
All right, thank you. So I just want to make a very quick summary because I know the last session was a bit rushed. I don't want to spend a lot of time on what happened, but just because I'm not sure if everyone was following along to read the cloud function part. So just to go, I'll give just 5 minutes to go and cover a bit about the cloud function. So at the very end with Anam, you were creating an action that will be used with our Watson assistant, because eventually you want the assistant to communicate with the machine learning instance that you built with Auto AI, correct? So just to go a bit over the action that Anam created. Which is dev workshop. So Anam created an action. She chose the Python 3.7 runtime. Basically, she just took the code from the GitHub repository that you already have there, and you just paste it right here. But again, I just want to focus on a couple of points. The first one is in parameters. You just need to put the API key. And I believe Anam already showed you how you can do this by simply clicking on the Manage button. Then you click on the Access IAM. We'll just wait a couple of seconds. Okay. And then in Access IAM, you will see here API keys. So just click on this blue button, create an API, IBM Cloud API key. Give it any name you want, and just go ahead and click on create. You will see that you have an API key. You can simply just copy it, and then simply just go back to your cloud function and paste it right here between two string quotations. All right. So that's the first thing. The second thing that I want to mention is about the endpoint link. So if you go to the code, you will see on line 16, I believe. Yes, here. No, sorry, not here. On line 63, sorry. Yeah, right here, there is this endpoint link. And this is the link that you already have from the AutoAI model that you built. Now, I don't currently have the exact AutoAI model that you're working on, but I'll just give you an example of where exactly you can get this in case you haven't already. Once you have already deployed the model and you promote it to your space, basically, when I believe Anam showed you how you can test it out, there is in the API reference this direct link, the endpoint. So again, this is where you will basically just copy and paste. So you take the link from here, copy it. There's this icon right here. Just click on this copy icon, and then go back to the cloud function that we have, and simply just paste it right here. And basically that's it. So enough of the cloud function. Let's go to the new stuff that we were going to talk about for this session, which is the Watson Assistant. It's going to be the highlight of the show for today. Let me go back to my home page. Okay, for some reason I can't. That's totally fine. 1 second, let me go here. All right, so basically, I think I'm stuck at the moment with the cloud function, but that's totally fine. You will see on top there is this search bar field where you can search for any service that you want. So what I want you to do is to search for Watson Assistant. So simply just type Watson Assistant, and you will see under catalog results we have the Watson Assistant service. So go ahead and click on it. And this will direct us to the Watson Assistant catalog service. Choose the location that you want. It's preferable to choose the exact location that you've already chose before with Anam. And again, make sure to go with the light free plan. Or in this case, just go with the trial. We have the trial one, which is as well free. So just choose the trial one. And then just give it any name you want. Check on the I have agreed to form the license agreement and click on create. Now, if you already have a Watson Assistant service that you have maybe created before in any kind of previous workshop, you can use the exact old one. So you don't need to go ahead and create for new one. But for those who have never created a Watson Assistant service, this is basically how to do it. You'll go ahead on the search, click on Watson Assistant, just choose any location, go with the trial, and click on create. I'll give a couple of seconds or maybe a minute to make sure that we are all on the same page before proceeding. And meanwhile, I'm going to open my Watson Assistant service. Okay. I think you've already seen this with but basically any service that you create on IBM Cloud, this is where you'll be able to see it in resource list under services and software. So in my case, I have my already existing Watson Assistant created. Oh, it's not on this account. Just give me a second. Okay. Okay, so this is my Watson Assistant. I hope by now you all have created your Watson Assistant. So we're going now to go ahead and explore it. Now, Watson Assistant is kind of, it's a tool by itself. It's a software by itself, so it has its own platform. Basically, this is like the main page of Watson Assistant. You will see the blue button right here, where we can go ahead and launch Watson Assistant. So we click on this blue button, which is going to launch us the platform of Watson Assistant. And it's in here where we'll be able to develop a chatbot, basically. And of course, this can be extended to voice bots, wherever you want. A virtual assistant. So usually, if again this is the first time, I want to make sure that we are on the same page. So if you're not seeing this screen, if maybe the first time they might ask you some questions, you just click on next and proceed. And at the very end, you're going to see either this or you're going to see that. I'm switching because at the moment there are two versions of Watson Assistant. So in case you are seeing this page, just give it a minute, it's loading. Right. So if you're seeing this kind of this page, this layout where we have get started by creating for assistant, assistant name, and all of these informational fields, just make sure to click on this icon here, like the profile icon. And what I want you to do is just click on switch to classic experience. So because maybe now if you're creating the instance for the first time, it might automatically shift you to the new experience. But what you want to do in this workshop, you want to go ahead and keep it up with the classic experience. So just again, click on this icon right here and look for switch to classic experience and click on switch to classic experience and then go ahead and click on the blue button, switch. So now this will give us back the old layout that we're currently seeing, like the classical layout, which is loading at the moment. All right, so this is just the traditional layout. That's it. You might see an assistant that's already for you, like my first assistant, something like that. But for now, just let's go from scratch. Click on the blue button, create assistant, give it any name you want. I'm going to name it dev Fest demo. You can give it a description, that's optional. Okay, and now this is what you will see. Like we have nothing, it's empty, we don't have any dialogue or actions. And now we're going to add a dialogue. So Watson Assistant cannot function without having either an action or a dialogue. Now, usually, just to compare these two, action is for more kind of lighter conversations. But if you want to make some more enhanced or customized stuff, we usually go with dialogue one. And usually dialogue is kind of the traditional way of developing assistants. However, today, kind of, these days with this new update, like we've seen with the new version that I was showing you, there is kind of more work that's happening on the action. But for now, to keep it simple, let's go ahead and use the dialogue as it's easier to customize it. So we're going to click on add an action or dialogue skill, this blue button right here. And we're going to move to the last element in the tab, which is upload skill. Okay. And now what I want you to do is basically to drag a file. Now you already have downloaded the repository. Let me go to the repository, the GitHub repository. There are different files that we have, and one of these files is basically the dialog-skill-demo.json. So this is basically the skill or kind of the conversation that the chatbot will have for our conversation. So if you go back to Watson Assistant, which is here. Okay, I lost my tab. Sorry about that. 1 second. Yeah, that's my page. Okay. So basically, what I want to do is just to upload the file. So just click on drag and drop. You will see the dialog.scale-demo, the JSON file. Basically, just go ahead and click on open. And now we click on the upload, and now we have our dialog skills already uploaded. So we wanted to make it easy for you. So instead of writing the dialog from scratch, we already have it for you. So all you have to do for now is just to upload it, and now we can go ahead and explore it. So I'll give a couple of seconds to double check if anyone is having any issues or something. If not, I will proceed. But for now, we didn't do anything complex. We just created the assistant. We clicked on the dialog here, and basically upload the file that you already have inside the GitHub repository, and we basically just upload it. So I'll go and explore. So basically, every dialog in Watson Assistant has three main components. So I don't want to say that every dialog. Let's say every virtual assistant itself. We have the intent, entities, and the dialog itself. So this is what Fawaz was earlier explaining in his presentation. The first element is the intent. And again, these are things that a user might ask. So kind of imagine them as topics. Maybe if you are, I don't know, you have a restaurant, let's say you want to build a virtual assistant for a restaurant. You can have an intent about opening hours, where a user can ask about this restaurant's opening hours. You can have maybe an intent about menus. So what kind of food do you have in this restaurant, right? So this is what I mean by intent. So it's like some topics that you will define, and you can basically imagine yourself as the user and try to think what this user might ask for this specific topic. Now, in our case, we want to again to keep it very simple, since today's session is mainly on the integration between Watson Assistant and WhatsApp. But that's why the phone only have one intent, which is about the loan. So it's already defined for you. If you go ahead and explore it, you will see this is our intent, and we have a couple of examples that have already been added. We have 4 examples. So basically, these are examples that we might think, but that the user might ask. So regarding loans. So in this case, I want to apply for a loan. How can I apply for a loan? Am I eligible to request a loan? So all of these questions are kind of defined this topic. And basically, this is where the NLU, so natural language understanding, comes into play. When at this moment a user is going to ask a question, it doesn't necessarily or actually have to type something similar to these examples. With the NLU, with the power of NLU, basically, Watson Assistant is able to kind of understand any queries that are similar to these. Automatically, it's going to build kind of a dictionary or a specific context for the specific queries or for the specific intent. And it's going to understand the question and it's going to match it for a long question. This is basically how the NLU works in here. And this is very fast, so you can actually, the assistant can start understanding these queries by having a couple of, 4 or 5 examples. Of course, the more the better, but like for now, you will see with only 4 examples, it will be able to detect what the user wants. So this was the first part, which is intent. Now we're going to go and talk about entities, which basically have two, the custom entities and the system entities. The custom entities is basically, the my entities. And in here, basically, what we mean by these, they can be defined as specific keywords that help to provide more context. In this specific case, you've seen with Anam that there are a lot of fields that we need to put to be able to predict to have our machine learning model to predict the score, like the status, credit history, the savings, housing, all of these. And what we want to do in this chatbot, we want to provide an interface where we can enter these information. So with Anam, you were testing these, you were adding these, I think, manually in the box, in the fields, or with a JSON format. But what we want to do is to provide a way, kind of an interface, in this case, we want an assistant, where the assistant is going to ask the user for this information, and we're going to answer. And basically, these information, these data fields that we need for the machine learning model will be, in this case, described as like all of these different values that you've already seen in the dataset. I'm not going to cover these at the moment to win some time, but this is basically what we mean by entities in this specific use case for today. And of course, we have system entities. Basically, these are out-of-the-box entities that comes automatically with Watson Assistant. And to give you a very kind of easy example, let's say the assistant is asking us what is the amount of the loan that you're applying for. So in this case, the assistant is waiting for us to give him a number. And we want the assistant to be able to detect this number. So how can we do this? By using system entities. In this case, you will see we have an entity, a system entity that's defined for number. By simply enabling this on, whenever I add a number, we can use this. The assistant can understand that this is a number, so it can take it and save it so we can use it later on. We can enable this as well for date. Let's say maybe you want for your restaurant, let's say a virtual assistant, a user wants to make to book a table for tomorrow. So if he says, for example, I want to book a table for tomorrow, the assistant is going to understand that tomorrow is a date and it will convert it to a date format. So this is kind of what we mean by system entities. We have for time, for currency, and for percentage. Now the last piece basically is the dialog, and this is where all the magic happens. Kind of we are merging everything together. Dialog are basically, or they consist of nodes, so that's what we call them, dialog nodes. And every node is kind of responsible to handle a specific part or a query or intent. In our case, we only have one intent, as I said before, to make it simple, which is about applying for a loan. So we can basically define a node, which is, we will give it a name, loan eligibility, just like SEC. And it can only trigger whenever a user is asking on the process of a loan. So as we can see, we have, if assistant recognizes the intent that we've already defined before, the loan question, then go to this node and process what will happen here. You will see by default the welcome and the anything else. These will always come by default, and then we can start developing more and more and add nodes. But again, we want to keep it simple, so we have only one intent. We're going to add only one dialog node where we can handle this specific intent, which is about applying for a loan. Now the thing is with this loan, as I was explaining earlier, the assistant will be expecting answers from the user to see if he's eligible for a loan, like the loan duration, loan purpose, loan amount. So we want to define all of these different information. And one way to make it easy for the kind of provide a better experience for the user is by using what we call slots. If you go to the customize button right here, you'll see that slots is enabled on, and basically this helps to gather information for our assistant from the user. Let's give a couple of examples. So the first thing that I want, for example, once a user asks about the loan, is the amount of duration that you want. So in this case, the assistant is going to expect a number that will be representing the days, right? And we want to take this, so that's why you will see here that we're going to check for system entity, the number, because we're waiting for a number. And we want to save this as loan duration. Now we'll see the entities are defined by add, the intent are defined by hashtag, and the variables that you want to save, what we call context variables, are defined by a $sign. So in this case, what's happening is the assistant is going to check for the number, and it's going to take it, let's say 10. It's going to create a variable called loan duration, and it's going to give it the value of 10. Once this is done, it's going to jump to the next question, the loan purpose. So what is the loan of this purpose? In this case, we have provided an option. So there are different things that we can add, text, like the previous one, image, audio, video, anything. But in this case, we're going to have an option because there are different options as you've seen in the dataset with Anna. We have other, car new, furniture, training, education, car use, and all of the others. So once we go to this one, the assistant is going to show all of these, and it will be waiting an answer from the user, who is basically going to choose one of these. And then it's going to create a variable called loan purpose with the value that the user just has, right? And again, the same thing will happen. In this case, what we're asking here in this one, in this slot, is the loan amount. And again, here we are waiting for a number, so that's why we're using this number. We're going to add, like, for example, 5,000, and we'll go ahead. We have different fields, many fields. We're not going to go all over them, but basically they are the same thing. So we're just asking the user for information, and we need to capture these and save them in context variables that are referred by $sign. Now, why are we doing this? Because we want to use these variables to send them to the machine learning model that's already deployed before. So the machine learning model can process and calculate the score so it can eventually give it back to the user. And how all of this is happening is by using the webhook. So to go to explain this part a bit more, let's go step by step. So what I want you to do at the moment is to go to your cloud function. Okay, let me go back. I will go to my cloud function, which is the one that you've already created with Anam, the dev festival workshop, I believe the name was. Okay. All right. The dev workshop, yes, that's the one. And in here, you will see under endpoints. So what we're trying to do here is make this cloud function accessible. So I'm not sure if you've already done this earlier, but if not, just make sure to enable this as a web action. And once you enable this, you will see that you will have this link available right here, under the HTTP method that has any, not this one, basically this one. Here you will see this link. So just copy this link, okay, and go back to your Watson Assistant. And under options, you will see webhooks. And this is basically where you will define the webhook. Now it already has a URL, so I want you to delete this existing URL and paste the one that you just copied at the moment. And at the very end, this is very important. At the very end, you need to add .json. Why? Because basically we are working with data in JSON format. So we can get this data, it needs to be in a JSON format. So you just paste the webhook right here. And now what we have done is we have connected this Watson Assistant to the cloud function that we have already created. So now if we go back to the dialog, we can start using this webhook. And it's already done for you in the basically in the customize. You will see callout to webhook is already on, so that's totally fine. And usually once you do this, you will automatically see the parameter section, and then you will see a return variable webhook, and then if that's the right enough. I'm going to explain this step by step. So the parameters one is basically parameters that I want to send from Watson Assistant to the cloud function. In our case, we want to send all of these data that the machine learning model needs to be able to calculate the score. So all of this information that the assistant was asking the user, we were saving them as context variables using the $sign. And now I want to pass these to the cloud function. And how I can do this in the parameter section. I'm going to give my parameter a name, and I'm going to give it the value, which is the context variable that I defined here, $age in this case, this one. And again, the exact same thing is happening for the other. And these names, all of these names, they are exactly matched in the cloud function. So they can be, referred to once we are sending this from here to the cloud function. So if I go to the cloud function, to the code, you will see these are the field names. So they can be, referred. I need to make sure that I am adding them exactly as they are, as in here. So this is basically what's happening. So now I'm creating parameters that has the value that I've already took from the user, and I want to send them to the cloud function. So once it's done, I'm going to get a return variable. And here what basically is happening, if the assistant recognizes the result, so what that means basically is once the cloud function processes the information and send the result back to the WhatsApp assistant, give me the response with whatever you want. In this case, you want to respond with the result that we get from the cloud function, which is which is basically stored in the message. So this is basically how the cloud function is defined. Because it's a JSON format, we're using the dot field. So in this case, we're having message, and this message will contain the score of the loan prediction. If basically we can apply or not. And to make a quick recap, we are sending these to the cloud function. The cloud function is then communicating with the AutoAI model that you built. The AutoAI is calculating the score, and then it's giving it back to the cloud function, which is again giving it back to the assistant using the webhook result. So message. It might be a bit complex, I know, but it's once you will go again read it back, you'll be able to understand. So this is for the part right here. This is basically how the webhook works. And if you click on try it, you can basically start, interact with it, just give you a brief kind of a glimpse of what exactly is happening. Let's say I'm typing, I want to apply for a loan. So to give you exactly a step by step what's happening, if you click on this, you will see that the assistant understood my intent, which is, it's regarding one question with a confidence score of 1, which is basically 100%. And basically, it's gone to this node right here. Why? Because I have defined that whenever we have a question with an intent of one question, I want you to trigger this node. So the way it works here, the assistant is going to check if this loan question intent is here, then it's going to go to this node. But it's not in here. So it's going to jump to the next node and check. Is it here? Yes, we do have one question. So we'll go ahead and jump to it. And it's going to start running it. So in this case, the first thing that we have is the amount of duration we want in days, which is this one. So 10, for example. Then it's going to ask what is the purpose of your loan, which is the second field right here. And because it's an option, it's going to give me multiple options where I can basically choose one of them. So let's go, for example, with car new. And then it's going to be the next question. What is the loan amount you're applying for? 5,000, for example. I'm not going to run all over them. I want to show you, we'll run it on WhatsApp. But basically what I want to show you here is if you click on the manage contacts, you will see all of these being created. Like when I entered the loan duration 10, it created a variable called loan duration with the variable 10. Then when I added the loan purpose, it created a variable with loan purpose with the value car. And the same thing for loan amount. All of these will be happening for all of these different fields. And again, we're doing this because we want to send all of these, we want to send them to the cloud function so they can be sent to the AutoAI and to be processed. So this is it for the Watson assistant part. And basically, at this moment, it is communicating with the cloud function, which is already connected to the AutoAI. But the last piece is basically connected to WhatsApp. So the way to do this is just click on this icon right here, assistant. And you will see that basically there is the banking, the DevFast demo here. You will see that we have integration 0. Okay. What I want you to do is click on it. So it's like we're going to the home page of our assistant, in this case, the DevFast demo. And we want to add an integration. So we'll see under integrations 2 boxes. Just choose the second one where we have choose a channel to deploy your assistant, something that Fawaz was earlier talking about in the presentation. So go ahead and click integration, scroll down to third party, and you will see WhatsApp with Twilio. This is the one that we need. Now, of course, there are other things that you can connect to assistant to. I believe someone in the comments mentioned Facebook Messenger. We offer this. It's right here. There is Intercom. There is Slack. Fawaz talked about them. But in our case today, we're going to focus on the WhatsApp with Twilio. There is as well SMS with Twilio. So click on the WhatsApp with Twilio, and then just click on create. Now for this part, we will be needing a Twilio account. So I hope by this time you already have created an account, because this takes some time to create the account. First time you need to set it up and answer some questions. And we don't have enough time. So I hope everyone has created an account. But again, the session is recorded and you have our contact details. So in case you wanted to repeat this at your own pace and you had some issues, just feel free to reach out. So anyways, click on create. Now we're going to set up this connection between Watson Assistant and WhatsApp. You see basically how we get started, nothing fancy here, just click on next, the blue button. And it's going to ask you for the account as ID. So now this is the time to jump to Twilio. Let me jump to this. So this is basically Twilio. This is how it looks like. So once you sign in, this is the main dashboard. Again, if you're signing for the first time, they will ask you some questions to set up your account. They might ask you why you are going with Twilio. Is it for a project, for anything? Just choose whatever you want. It really doesn't matter. Once you answer all of these questions, you will see this specific page. And what I want you to do is, at this moment, to take the account as ID right here. So you click on this copy icon right here. You go back to Watson Assistant, and you paste it. Okay. And then we click on next. The second thing that we need is the oath token. Now we go back, and you will see here under the account as ID, we have a field called oath token. We'll do the exact same thing. We're going to copy this. We click on the copy icon. We go back to the assistant and paste. Okay. And then we click on next. So now this is a webhook, another webhook. This is not the same webhook that we were working before. This is basically a webhook that is uniquely defined for Twilio to be able to use it for WhatsApp. Okay. So I want you to copy this. All right. And go to Twilio. And now we're going to start adding the WhatsApp part. So under here, you will see on the left side the messaging. I want you to expand this, and then expand try it out. You will see send a WhatsApp message. So we are messaging, try it out, send a WhatsApp message. Click on this one. Now, because this is a trial mode, so we're going to kind of work in the Twilio sandbox to integrate WhatsApp. And this is what we're doing at the moment. We're going to create this sandbox. It asks you that to begin testing and to connect this WhatsApp to the sandbox, you need to add this phone number to your contact and then give it the code join post coming. So I'm going to do this, and I'm going to actually share my phone screen with you so you can see exactly what's happening. Okay. So actually, I have to, one second, this will take a minute. New contact chat. I'm going to set now the message, and then I will share my screen just so we can wait some time. So at the moment, I'm typing join post coming to Twilio to this number. And at the moment, we have seen that the message is received. Okay. So I'm going to now click, once the message is received, you can simply just click on next, send a one-way message. Basically, you can skip all of these, and then it will ask you to the next two-way messaging. Again, click on this. We were not going to do anything on these. And the two-way messaging, we don't need it as well. So we can click on next again. So at the moment, we click two next, and now this is the third next. So we're just kind of skipping them. So next, this is basically the last part where we want to configure the sandbox. Okay. So now what will happen here is we're going to add this webhook that we just copied from Watson Assistant to write this part right here. So in this field, when a message comes in, I want you to remove this thing, okay, and paste the one that you just copied right now. And you will see basically the number, your number. In my case, because I made a chat with this specific number, so the number now is automatically added. In case you want your friends to as well connect to the sandbox, they will need to send the join post coming code. In your case, it might be another code, another term. In my case, the join post coming. But again, they will need to send this to this number, and it will have the user here added. And once we do this, we click on save. Okay. And that's it basically. Now I'm going to go to Watson Assistant, and I'm going to click on finish. And what I want to do right now is I want to share my phone screen. So let's do that. I have a software here called Visor, which basically reflects whatever I see on my phone screen, it will be reflected to the screen, to the laptop screen. I'm just right now. Okay, this is my Android device. All right, so perfect. So I hope you can see my screen. I think it might be a bit pixelated. This is from Visor, but I think it's fine. You can see it. So basically, the message that you're seeing right now, the join post coming, is the message that I sent to set up the sandbox. And once I will receive it, it has added to the sandbox. You're all set. And so now, if I click on, for example, I want to apply for a loan. One second, let me check that system. Okay, I think there might be an issue here. I'm not sure why. Oh, okay, I need to sync the account. All right, so okay, at the very end, once you're done with that, you'll see the account as ID, the auth token, and you'll see this sync account. So just make sure to click on the sync account. I think I forgot to do this before. Now it's synced, and we already have our webhook pasted. So let's go with save and exit. So I'm going to try one more time right now. If not, I will use another instance because I'm afraid this might cause an issue. Okay, still nothing. All right, let me go back to my assistants. I'll leave, I'll shut it down, then I'll make it back online. So 1 second. Stop. Okay, let me go back to Twilio. Messaging, service, try it out. In your case, you might not face this issue. I might facing this issue because of my already existing chatbots that I have already before connected with Twilio. So I think this might be a connection issue with this and the other instance service that I have. But I'll try again anyways. Join, post. Okay. Now I can connect at all. Your number WhatsApp is not connected. Okay, 1 second. Let's do this. Wait, actually, I'll show you what I'm doing. I'm going to delete the chat. Okay, delete, and let's try to add Twilio again. So now if you try to add join post coming, that's weird. No, it's not working at all. Okay. Let's try one last thing. Let's do the following. All right, join post. Okay, don't try from another number. Let's try this one. Okay, I'm going to click on next, and configure the sandbox. And I think what the issue might be is I'll try to remove the other integrations that I have just to double check. So let's delete this one. Again, I don't think you will be facing this issue. This is just from my side because of the different service that I have at the moment. Okay. Copy this one. Put this one back again. Where is it? Okay. Close. All right, then let me add this back one more time to double check. Okay. I'm gonna click on save. All right, now I'm going to try this one more time. I'm not sure if it will work this time. All right, so now it's working as we can see. It's now asking me for the amount of duration that I want in days. In this case, let's go with 10. Again, I'm sorry about the issue. I think it was because I have two different values connected to the same system. So what is the purpose of my loan? I'm going to go with car new, so I'll choose number 2. So here you will see that it gives us reply with the option number as like it's a multiple choice. What is the loan amount that I'm applying for? Let's say 5,000. This one I'm going to go with 2. How much savings? Let's go with the second choice. How long have I been employed? Let's go with the first one. Let's go with 7. Any other loan overdue? None, which is number 1. Do I own a property? Let's go with the saving insurance. Here, let's say 25. Any installment. So all of these data that you're saying, these are the exact data that Anna was using in the Auto AI model. So that's why we are getting asked all of these questions, because this is what we need for the model to be able to predict the score. I think we still have one last question, 2 questions. So let's say, for example, I have 500 as my existing first count. Job is skilled. So now what happened is all of these data has been sent to the cloud function, and the cloud function, because we were using the concept of parameters, it took them and then it sent them back to the Auto AI. It's already connected in the code, and the Auto AI calculated the risk. In this case, the risk probability is 24%. So there is no risk loan application in this case. So basically, this is how it works. Again, it might be a bit complex if you're new to the concept, but it's pretty straightforward, especially the integration with WhatsApp. We didn't do anything. It was just a couple of clicks. When you do it, or if you didn't try it right now, I'm sure you're not going to face the same issue I faced. This was, again, because it has multiple services connected. But again, that's it. Basically, this is how we can integrate WhatsApp with WhatsApp Assistant. And we have actually used a machine learning model that you built earlier in the session to predict the score. So that's it from my part. I believe Fawaz will make a quick summary and conclude this session. Fawaz, this floor is all yours, buddy.
So much for you. Very interesting. Alright. Khalil first hands-on workshop. And it's all about automation. About with the environment, ML with the chatbot to check if the user can finally deploy it through Twilio for experience. Next thing is an assistant. Well, there's where you can integrate multiple. There's SurveyMonkey, your telephony service, and deeper, much more. What's an assistant? So I'll this session some useful links and bunch as Fawaz Raj to scan the barcode. Thank you.
Fawaz, I think for me the sound is a little mixed up.
Alright,
Yeah, same for me as well. So, but you can please refresh.
alright, just
So Fawaz is just reconnecting.
I was on mute, sorry. If you have any
All right.
questions, for Fawaz. Oh, Fawaz is back.
All right. I don't know how much of that have you heard, but if you can guide me and I can go back.
I think starting the summary again would be good.
Right. That's perfect. Let me push that up. So let's summarize what we've done, right? So we built a machine learning model using AutoAI/AutoML, and basically it was predicting the loan risk. And then we built a chatbot in a low-code environment, and we integrated the ML model that we created using AutoAI through Cloud Functions to check if the user can apply for a loan. Then the next step for improve UI and UX experience for the user, we integrated that chatbot to WhatsApp through Twilio. So that's what we did. In some simple steps, we were able to deploy a chatbot to WhatsApp. And this can be, like Myrtle mentioned, it can be done in multiple industries, in multiple scenarios, in multiple use cases. The steps are always the same. It's just data is different. What's next for Watson Assistant? Well, there is a seamless integration. Remember the web chat integration that we talked about? Yeah, now it's getting more seamless, where there are more out-of-the-box support for videos, audios, and iframes. There is easier telephony services integrations, deeper conversation analysis, and much more. We do have these things covered up in the Watson Assistant learning path. I'll be sharing the link to that once I end the presentation because I need to copy it. And these are some useful links that you can check out. And we'll be posting the GitHub link as well. And thank you so much. My name is Fawaz Siddiqui. And with me, I had Khalid Faraj. You can reach out to us on our email. You can check for my LinkedIn, my Linktree. And do let us know how we did. Your feedback is very important to us. So you can scan the barcode or go to the survey link and give your feedback. Thank you so much. And thank you so much, everyone, for helping out.
Yeah, thank you so much for a wonderful workshop. It was really cool to see how you can upgrade your chatbots and all the possibilities of connecting them to different platforms and services. That was amazing. So thank you both very much.
You're most welcome.
Yeah, we've been posting the link for the feedback for the survey link to give your feedback in the chat frequently today, but if you've missed it, it's just been posted by my colleagues in the chat there. Thank you very much. And this concludes day one of our developer festival. We've had 4 amazing sessions today. If you're not signed up for the day 2 and day 3, please make sure you save your spot here on Crowdcast. It's a different link, but don't worry, we'll be sending all the information through email as a follow-up. For tomorrow, we have another 4 amazing sessions. We've got some open source in Java and the focus also on AI for the rest of the day. So we've got project beta, we've got building and scoring Python models, and also ethics and artificial intelligence. So don't miss that. On Tuesday, we also have a learning series starting. It's 8 parts. And it's all about data, AI, and automation. So that takes place over 8 weeks. Be sure to sign up for that if you're interested in accelerating data, AI, and your journey there. You can see on the screen there's an overview for what sort of things to expect. This will run into next year as well. So it's a bit of a longer series than our festival, which is just these 3 days. And I've posted a link to the Crowdcast there in the chat. So then we have just one more slide from my side. The agenda for Wednesday, is all cloud focused. We've got microservices on serverless, OpenShift, and CI/CD for Kubernetes. So another lot of hands-on workshops for you, all here on Crowdcast. And yeah, we look forward to seeing you. Thank you so much for joining us today, and looking forward to seeing you tomorrow and on Wednesday and at future events. Thanks, everybody.
Thank you, everyone. Take care.